Hi everyone, my name is Alexander Dunaev, and this is the second day of Winter Data Meetup. Thank you that you are staying with us. So today we have again 10 interesting talks. And I want to introduce the first speaker is Mikhail, who will share an interesting story of uh, applying machine learning and text labeling for solving a real problem. Yeah, Mikhail, please.
Mm, well, I hope you can see my screen well.
Yeah.
So hi everyone. Thank you all for coming here today. First of all, let me shortly introduce myself. I'm Mikhail Bulgakov. I've been working for EPAM as a data scientist for 1.5 years and have about 3 years data science projects experience in total. I've participated in several projects of different machine learning and business domains. And basically, I'm interested in NLP tasks, but I have also had some projects behind about classical machine learning and computer vision. Um, yeah, so my presentation focuses on the project we recently developed. It's about how we created a named entity recognition model to extract entities from email messages. Uh, and I hope it's gonna be interesting for you to listen it. Maybe you can find something useful here for your project or activities. So let's get started by considering the problem. We had a following business request. There is a support portal where one can initiate request creation by filling out special request form. You can see it at the slide. This is the most preferable way to ask support team to get any help, but there is one less preferable but very often used way to make a request, sending email messages. And the problem is someone from support team always needs to take the message, read it, and after that fill out the form. According to the statistics, there are up to 20% of 45,000 requests received by emails every month. So you can imagine how time and resource consuming this procedure is. About 7,000 email messages to process manually every month. So the main purpose of the project was to eliminate this gap by building the model to automatically detect necessary entities and reduce time that support team spends for this process. So let's begin with considering main features of the data we had and the task in general. First is variety of data we had. We had a lot of categories of possible emails and a lot of different entities in each category. Sometimes entities are typical for categories, sometimes intersecting over some of them. You can see examples here on the slide, messages from two different categories. Project management category has specific entities like project ID and project role, blue and light green colors here. But for hardware issues categories, there are different unique entities, resource, yellow color, and issue, dark green. Uh, these categories don't intersect between categories, uh, but we also have name and entities, name and entity and action entity, sorry, uh, corresponding red and purple bounding boxes. That are common to these two categories. Actually, to all categories we have, but however, it's just an example, and the set of possible entities and categories is much wider than at this example. So next feature of data we had is that our emails often contain large number of replies. Look at the example. The main part of email is bolded here. So we need to figure out whether it's necessary to process whole message or not, because in the output can be too many extracted entities then. Yeah, let's move on to the next point. Also, there may be several requests in one message. You can see at the example that there is one request to exclude someone and another one to include someone else. Honestly, it's one of the biggest problem we had because we figured it out slightly late and got some additional work in the final stage of the project. And the last feature, but also very important, we didn't have any labeled data in the beginning. And also we didn't have any labeling strategy provided by customer, so we had to come up with it ourselves. And finally, we didn't have much time to label data by hands because we were very limited in time. So this is it about task features. And next slides focuses on how we dealt with these challenges and what decisions we made to label data and train the model better. The variety of different categories and entities may lead to some problems. If we train one model for all categories and for all entities as well, we can face some difficulties with model quality. For example, it could be really unstable because of entities imbalance, and and also it's hard to fine tune so general model, paying attention to every entity detection quality. So we decided here to split all categories into groups based on typical entities, and after that, train independent model for every group. This is a way to reduce entities imbalance influence and maximize model quality of working with specific entities. And every model is tailored to detect basic and specific entities. You can see it here at the picture on the slide. Every model is able to detect general entities like name, emails, action, and so on. And also detect entities that are typical only for this group. Finally, we bring all models outputs together and do it at the post-processing stage. Next, our decision was to train model on messages including all replies. Although it's obvious that we need to extract entities only from the last message because only last message always contains actual request formulation, but the huge number of replies allows us to get much more entities to train on. So we decided to label whole messages and leave question about what entities to return for afterwards post-processing stage. But the most interesting decision we've made is about labeling process. In the standard process, we need to label all the data first, then train, fine-tune, and evaluate models. We didn't have an opportunity to go this way because it would take extremely much time to label all entities in every message. So we decided to use Label Studio framework here. It's not just because it's useful enough tool, but also because it has a very interesting possibility to automatically label data. You can write a Label Studio wrapper for your model, start Label Studio ML server locally, and get the opportunity to easily use predictions of already trained model to label next data. All you need to do manually is look at the predictions and correct them if it's necessary. You can see it at the scheme. We'll label very little bit of data by hands using Label Studio user interface. Then train first iteration of model. By the way, it doesn't really matter what machine learning framework we use. Next, we start Label Studio ML backend, and I can say a couple words here about what it is. Label Studio ML backend is a software development kit that lets you turn your machine learning code into web server. Shortly, how it works: you take your model, model code, uh, wrap it with the Label Studio SDK in a special form, create and launch a running server script, and connect Label Studio user interface to this backend. So finally, you have an ability to label your data in Label Studio UI using already trained model. And that's what we actually needed. Uh, After we have a backend with the first iteration of model, we label next batch of data with manually corrections, and then train model again with more data. And do it as many times as we want until we label all the data we have. Finally, we get all data labeled and model fitted on the whole set of data. And a couple more advantages we have using this iterative procedure of labeling. One of them is well-tuned tokenizer we have, because while you're checking predictions, you can notice almost every mistake caused by incorrect tokenizer work and fix it. And also, since we correct all labels during labeling process, we always able to have very good test set without any additional work, because every our test set is manually corrected. So now let's see how long did it take for us to label all the data using this way of labeling. You can see here on the chart how we labeled all the data and trained models. We spent approximately 1 week for one model. Every color line here shows labeling process for corresponding model. Breaking gray line is our estimation of fully manual labeling speed. In other words, how much data labeled we would have if we had processed constant amount of messages every day, like first 2 days. So we see here that gain of using our way of labeling is really significant. Differences between color lines caused basically by different messages and categories. For instance, requests about replacing hardware are usually shorter than requests to change something in internal company systems containing a lot of approvals. That's it about labeling process. And now let's talk a little about models we trained. We decided to try two different models: model provided by Spatie framework and transformer-based model from Hugging Face framework. Why these two? Because these two models have completely different architectures, and it's reasonable to compare them. Spatie model is convolutional model, but Hugging Face is based on transformer architecture. We finally chosen Spatie model basically because of two reasons. We've got quite comparable performance, but Spatie was faster and much lighter. Next, here you can find final evaluation metrics we've got. These are average entity classification metrics for every model. We made a validation on manually corrected test set for every model. We left 20% of data for this evaluation stratified by entities. You can notice that some models have worse metrics than others. It's because some entities are more complex and harder to recognize. But still, these metrics look pretty good. Next slide focuses on post-processing we've done. But why we actually need post-processing here? Why don't we just give the result of our models to user and that's it? Main reason is that we still have some problems after labeling and training decision we've made. First, we process whole messages with all the correspondence, and the result often contains unnecessary entities from replies. Second, we do nothing with the situation when there are several requests in one message. Also, there were some additional business requests about format or final result they wanted to see. So we definitely need in some post-processing layers to prepare models outputs for final usage. And let's discuss that post-processing procedures from the side of problems we just mentioned and some others. We've made a decision to train on whole messages, but in the final result, we of course need to have entities from the last message. To take on the last message of correspondence, we implemented the algorithm that splits message into parts based on common letter ending patterns, and the output of the model contains only entities from the last message. You can see it at the slide here. Um, Common letter ending pattern here is best regards, um, and yeah, in the final result, we see only entities from the first part of the message before this pattern. Since we have a sorry, since we have a combination of models uh, applying in parallel, there are two possible problems with combining their outputs to the one final result. Uh, all models can extract some general entities, so there is a possibility to have conflicts between models in these entities. And also we can find unnecessary entities for some category. So we implemented the algorithm of entity filtering. You can see an example how it works here. We choose entity with maximal length if there is a conflict. And we have a possibility to give a list of entities you expect to recognize, and the model is able to drop unnecessary ones during the process. And a couple more challenges we left for post-processing stage. One of them, there was a business request to indicate if we found some entities existing in company glossaries. For example, names, project roles, titles, and so on. So here we made an entity mapping procedure where we map found entities to existing elements of glossaries. And the last problem we had is a possibility to have several requests in one message. We have already mentioned this problem. It was one of the biggest challenges for us and the largest improvements we're still supposed to do. We didn't have much time to implement something more complex, so knowing that the base entity in almost every request is action, uh, you know, add something, initiate something, remove someone, all these are actions. We decided to split message by actions and get several requests based on so very simple assumption. We called it complex entities creation. It works pretty well for big part of cases. So for now it's enough, but still it's very big field of improvements. That's it about post processing. And now I have couple more slides left to sum it up and make some conclusions. Here you can see a general scheme of our service. We have already discussed almost all its elements, and I placed it here just to bring it all together. We have two services here: Model API based on Fast API framework, and Job to regularly update glossaries. So summing up, the process looks like we send JSON with requests to the model. Model's outputs go through post-processing layers, and we finally get the resulting JSON with predictions to send back to user. Yeah, this is pretty much all I wanted to tell you about this project. The last thing I would like to mention is improvements we're supposed to be done. The main thing is, since we have very simple rule-based algorithm of complex entity creation, we can implement something more complicated. For instance, model with entity relations. After we get the result of user experience testing that is currently taking place, by the way, we will adjust some parts of our labeling strategy. And also we are planning to extend the number of categories to process, because now there are only the most necessary ones for business. Yeah, that's all I wanted to share with you about this project we developed. So if you have any questions, you're welcome to ask. Yeah, and thank you for your attention and for your time.
Yeah, thank you, Mikhail, for a very interesting topic and yeah, your project. So of course we have questions, and yeah, we have some questions from in YouTube. Maybe you can. Uh, I don't know if you understand it. Can I depict this labeling procedure as follows? The model that label data for itself iteratively.
Could you repeat, please, the formulation? Yeah.
Can you see it?
Yeah. Can I depict the labeling process phone? There's the model that label data for itself iteratively. Uh, Not really, because better to say we iteratively train model on different parts of data we have. We label data and train model iteratively, step by step. Uh, and every next step have more data to train on that previous ones. So and we have possibility to do it really fast, because we use pre-trained models to label next batches of data.
Okay. Hope we answered the question. Yeah. Next we have is developed model could be reused on other projects for other customers. So yeah, maybe for example, what if we receive emails from customers about I don't know, platform failure, and can we create some Jira tickets automatically?
I think
What do you
yes,
think?
but we need to adjust the process and the model. I think we need to somehow to retrain it, because we fitted it only the the messages we have. So but in general, I think this kind of training process should be can be implemented really good in really wide amount of tasks.
Yeah. And could you give more details about this training process? So how many emails did you have at the beginning? You told about iterative process. So how many did you have at the very
Yeah,
beginning?
the best way to illustrate it is to look at this graph. I've already shown it. Yeah,
Mm-hmm.
and this is exactly numbers of messages we labeled, and the
So at the beginning
x
about
axis.
50.
I think it's something like that. Yeah, we started first 2 days we labeling like 50 emails, and then we started this process, and we see the difference. The
Mm-hmm.
Again, gray line here is the situation if we label, like, as you said, 50 emails every day.
Mm-hmm. And how many people do you have for labeling? How
Our
long
team
it take?
was like two data scientists, me and my colleague. Yeah.
So and actually data scientists labeled, but
Yeah,
is it possible for example, to invite somebody else who are not data
yeah,
scientists?
but we didn't have an opportunity to ask somebody for help, so
Mm-hmm.
we've done it on our own.
And yeah, could you give me details about some technical, yeah, some hardware that was used for this model creation? So have you used some special, I don't know, uh, geographic processor, GPU or something like that?
No, we didn't use some GPUs. We trained it on our local computers, so
Mm-hmm.
it's not really great amount of data to use GPUs.
Mm-hmm.
But I suppose if you have like hundreds of thousand emails, you need to use GPU then, at least for training Hugging Face transformer models. Yeah.
Yeah, so you mentioned about this Hugging Face model. Yeah, you mentioned that you compare those two models, Hugging Face and Spacey, and you've chosen Spacey. That this was so it was better for your situation. So does it mean that Spacey is always better than Hugging Face, and Hugging Face shouldn't be used for
Mm,
such tasks?
no, of course not. It doesn't mean that Spacey better in all the cases. I think I can say maybe in most cases, Hugging Face is better, but for our case, we had not really great amount of data, so we had the possibility to use um, Hugging Face and Spacey in comparison. But yeah, it definitely doesn't mean that Spacey better in general. So I think you always should compare
Mhm.
and see how it works for your specific task.
But you have chosen only these two models, so maybe there are some other.
I think for Hugging Face frameworks, there are plenty of different variations of transformer-based models. We trained the simplest one, the lightest one, because we didn't have again some GPUs to train it.
Mm-hmm.
So, but in Hugging Face you have a lot of different models to train. So yeah, as in Spacey as well.
Mm-hmm. And yeah, and do you implement, or maybe you're going to implement feedback loop, or to improve model quality?
Mm, I think it's
What
it's
do you
it's
think?
not question for me. It's better to ask the business about this, but I think it could be really helpful to have some feedback form when user gets some errors in predictions. He can like report the errors in some form. It would be really helpful from my point of view. Yeah,
Yeah,
but we
something
don't have.
like that. Yeah, my email was not labeled properly, or yeah,
Yeah,
parsed properly. Mm-hmm.
but
Okay.
we don't have such a service now,
Mm-hmm.
unfortunately.
Yeah, and so I do support only ticket opening procedure, or with email, or also you need to support ticket modifications and deletion. For example, yeah, when you open a support ticket, they can request more details, something like that.
Mm, now we have only opening opening requests process. I don't think it's really easy to
Mm-hmm.
to create something for modifications, but yeah, I think we can think about it, but for now we have only opening tickets requests. Yeah.
Uh, okay, yeah, looks like we don't have any more questions. Yeah, right. Okay, yeah, thank you, Mikhail, for your presentation. Very interesting project and topic. So hope you will succeed in your direction. So yeah, and
Mm.
our next speaker uh, is our next speaker will share uh, all details about Snowflake. So please stay with us. Our next talk is in 15 minutes. Yeah, thank you, Mikhail, once again. We are back. This is Winter Data Meetup, and our next speaker is Shidhar, and he will tell everything about Snowflake. So if you haven't heard about it or didn't have enough experience with Snowflake, hope this talk will bring you enough knowledge. So please enjoy. Shidhar, floor is
Yeah,
yours.
thank you, Alexander. Hi, all. My name is Shidhar Pothamsetti. I'm working as a lead software engineer in EPAM systems. I'd like to explain about Snowflake and its implementations, how it can be used, what all the features it is giving to us as part of this data winter meetup, as part of the data gen community. So to speak about myself, my name is Shidhar Pothamsetti, as I said, and I have total 13 years of experience, and I'm completing 13th year today. And I got chance to work on multiple domains like banking and financial services, telecom, retail, and logistics. And tech stack is mainly into like big data, GCP, Azure, AWS, Databricks, Snowflake, and data warehousing related technologies. So I carry a good amount of experience in migrations and implementations from scratch with respect to big data and cloud with respect to the data engineering. So to start with, like anybody like here having like some experience on Snowflake or like got chance to work on the Snowflake?
Yeah, looks like our audience had some experience, but not deep,
Okay.
and half heard about it.
Okay, so I'll try to explain in detail from the theoretical perspective and how we can take it forward to the next level by working on these things. So moving towards the contents, what all the things I'll be covering today is like mostly Snowflake overview and how it transformed from the previous traditional technologies to now, and then the Snowflake architecture, the data organization, and then the key features, Snowflake integration benefits, and then the use cases we do have, and what are the best practices we can follow, and what all the upcoming features are in line, and what are the limitations we do have when we are using the Snowflake. Okay. So to start with, Snowflake overview, like what exactly is Snowflake? So as part of the data world, we work on multiple technologies like traditional warehouses, data lakes, and all these things, right? So Snowflake is actually a modern day warehouse or like lake house. We can say like recent days it got transformed into lake house because of the introduction of few programming related things and all. So it is actually a cloud data warehouse built on the top of the public cloud infrastructure. So we do have public cloud like AWS, Azure, GCP, and yeah, it's actually a true software as a service offering. Okay, so when I say software as a service offering, there is nothing to install or like nothing to configure, something like that. So directly Snowflake will be providing us the service. We can create an account, we can log into it, and then we can start using it by selecting the power we want to use, like the storage, the compute, and all these things. So it's actually maintained completely by the Snowflake, and it's like easy to use service. So what are the things it will be supporting? Like, so it provides a single platform for all the different types of workloads in the data world. So the first one is like data warehousing, data lakes, and then the data engineering, data science, data application development, and the data sharing in secure mode, and also the like consumption of the real-time data and like sharing it across. So if we see, like, we call it as a data cloud data platform because of all this support it is providing from the data perspective. So the slide I'll be covering in the next slide. So I'm moving ahead with the next one. So how the journey is like transformed from the existing traditional on-premises based enterprise data warehouses into the current cloud data platform or current cloud lake houses. So the first one is like on-premises EDW. It's like Teradata, Netezza used to be there, and people started using those things in the olden days, right? So because we worked in the on-premises environment, we don't have the ability to take all the data, and also it's extract, transform, and load, right? So mostly we will be transforming the data and we will be loading the transform data only. So because of that, all the data is not available, and all users, we will not be able to give access to all users because it is need to know basis, and like we will be able to share with the corresponding users only, and it's not like available everywhere in the world. So next one is like on-premises based enterprise data warehouses generally support fast answers because of it, transactional support and all, and also SQL database kind of functionality is available there. It's the same case with first generation cloud EDW also, the third one in the screen. So it is like Redshift when it is implemented in the initial days. It has some flexibility compared to the on-premise EDW, but still the all data and the all users problem was there. And when it comes to the data lake, we can load all the data. It's like ELT, right? Extract, load, and transform. So we can load all the data. And from the user's perspective, again, it does have the problem of sharing all the data across the world, and everybody can't access it from everywhere, right? And fast answers, it is because of the batch processing. We are not able to get the fast answers. It is mainly for the batch processing purpose. And then SQL database kind of functionality is not there, and it is like schema on read. So like when we are reading, then only the schema will be tested and all these things. So coming to the cloud data platform, it solves all these problems. Like we can share all the data with all the users, and we can load all the data, and we can get the fast answers because of the transaction support. And we do have SQL and SQL support for this one. So the journey is like the transformation happened from the on-premise data warehouses to the current cloud data platform, or like we can term it as lake houses also these days because of the introduction of Snowpark and all these things into the environments. So moving to the Snowflake architecture, how is it different from the existing things, right? So as I said, it supports all the public cloud infrastructure like AWS, Azure, and then GCP. So our data can be stored in any of these clouds. So it is like cloud agnostic layer we do have, and centralized storage. We can have common storage for all the services we want to use, or like all the data workloads we want to use. And multi-cluster compute, we can get the virtual warehouses as part of this compute in t-shirt sizes for different workloads. So might be like I'm from the data warehousing team and I need a small cluster, so I can take it, and there is another person who want to use it in the form of interactive mode and he need the small x small size. So then he can get that size of compute for his purpose. And another person from the data science team, they want the more powerful cluster, so they can get the more powerful cluster as part of these virtual warehouses. And it can scale out in the form of multiple clusters, and also it can scale up for the existing machines also. So if we see here, Snowflake provides us the services of optimization, management, transactions, and security and governance, metadata management internally, and then sharing and the collaboration. So here we can discuss about the Snowflake architecture components. So if we see, we start from the down layer, which is the database storage. Whenever we want to store the data from like our local machines, or like from different clouds, or like from external machines and all. So we, like Snowflake, what it will do is like it will try to reorganize the data. It will optimize it. It will compress it, and it will store it in the format of columnar data. And the micro partitions will be stored so that like the data can be fetched faster. So Snowflake actually stores this in optimized format, as I said, and it take care of all the optimization needed to provide the data back. And from the query processing perspective, we have a processing layer. So here the concept of virtual warehouses comes, and it will help us to process the data for the different types of workloads. So on the same data, we can have multiple virtual warehouses created by different teams. Like as I said, my team is data warehousing, or another team data lake, another data science team is there. So they can create separate warehouses on the same data, and they can start querying the same data for their purposes, and it will serve all those. So each virtual warehouse is like a kind of massively parallel processing compute cluster composed of multiple nodes. As I said, they can be scaled out or scaled up accordingly based on the need of the users. And Snowflake provides services like in the form of cloud services layer. It is like providing infrastructure management. So when we get the account, like we can get the storage, unlimited storage, and then unlimited compute power, and also the optimization internally. Metadata management also happens in the form of Foundation DB. And then the security, like data at rest will be secured, and data in motion is also like secured. So it is like secured everywhere. And then authentication and the access control. So if you want to have different types of roles available, like security admin, account admin, and the custom roles and all we can create as part of this cloud services layer. So moving to the closer look of these architectures. So we do have traditional architectures like shared disk and shared nothing architectures. When it comes to the Snowflake, it is a hybrid version of these two. And in shared disk architecture, additional capacity actually requires the forklift upgrade. That means like if you want to add some capacity or if you want to migrate from one to the other, we need to take the whole data and we need to move it to the other system. And also like at the same time, if you want to do the read and writes, it will trouble the system. And also like if you want to do the replication, we need the external hardware. So from the shared nothing perspective, resizing the cluster requires redistribution of the data. In Hadoop also, when we add nodes and all right, generally we try running the redistribution commands. So similar to that, we need the commands to redistribute the data or like resize it accordingly. And shutdown also is needed if you need the unloading of the data. And each like if we want to have like some dev cluster, test cluster, or high availability cluster, so then we need to have different copy of data. So like the data will be duplicated onto the systems if it is like a disaster recovery method, or like if we want to have another copy of these things. And also like if we have skewness and all, or like distribution is not even, so in that time we will be using the vacuum commands and all right. So it needs shortened distribution for the performance perspectives. And when it comes to the Snowflake, as I said, it is a hybrid version of shared disk and the shared nothing architecture. It's like a multi-cluster on the shared data, where the data is stored on the public cloud through which the Snowflake account is being provided. And it is actually centralized, and the storage is like kind of scaled out mode. It needs to be, if it needs to be expanded, it can be expanded, and if it needs to be contracted, it can be done automatically. And even independent compute clusters provide us the ability to read and write at the same time. And accordingly, we can resize them instantly. If we don't need that much power, we can reduce it accordingly. And automated backup also is available because of this cloud provisioning. It is available in multiple zones and multiple availability zones and the regions. Because of that, we can have the automated backup running for our data and the processing. So as I said, AWS, Azure, GCP are the major clouds which are supporting the Snowflake. Whenever we create the account, we can select which of these services we want to use. So moving to the traditional versus modern data architecture. So traditional data architecture, if you see, right, it's mostly complex and costly with multiple copies of data. So we'll be having different services like coming in the form of sources like OLTP databases, enterprise applications, third party, weblog, IoT, etc. Right. So the data integration can happen with help of extraction, transformation, load tools, and then the change data capture or streaming. So the integration can happen in any of these ways. And then the data transformation can be done using different ELT tools or the techniques we have, like Hive, Spark, any of these things can be used to do the transformation. And then the normalization and aggregation will happen in the third layer, which is like loading the data into the data warehouses, data maps, data marts, and then the backups. And then the data will be like created for the reporting purposes or for the downstream systems like data science teams, and then like shared in the format of files for the final consumers. So this is like a kind of complex architecture which will be having like multiple copies of data available in multiple places, and storage and compute is tightly coupled here in the traditional mode. When it comes to the modern data architecture with Snowflake, as I said, right, the cloud is providing the storage and it's the common data. So if I choose my Snowflake account with Azure cloud at its backend, so my data will be in Azure cloud, and the same data can be accessed by different teams or different workloads. It's like data warehousing team, data lake team, data engineering team, and then we can share the data with other teams also. And it is available for faster processing purpose. Sometimes I might need it to be like in interactive mode. Sometimes I need it to be processed in very powerful processing mode. It can be done very easily with the same storage, and just I need to change the compute power with the virtual warehouses. So if you see the diagram, it's like a very simple architecture, and the storage and compute is completely kind of decoupled, and users have the flexibility to choose their processing power accordingly. So moving to the next one, which is the data organization in the Snowflake. So whenever we want to use the Snowflake, the highest part, or like the top most object we'll be getting is like the account. So we can register for the Snowflake account and we will get the details. So, and inside that we go into the next level, it's database. Just like other databases, we can create the database and the corresponding schema. We can create schema also, and then inside that we'll be having the table, views, and stages objects. So in Snowflake, the new concept is stages. It will be helpful to act as an intermediate layer before loading it into the tables from external storage like cloud, Google Cloud Storage, or Azure Data Lake, or S3 storage. So the stage will act as an intermediate layer to load it into the tables. So if you see, the tables are of different types, like permanent table, temporary table, transient table, and the external table. So I'll explain these things in better in the next slides. And these are exactly like the existing ones. And views are also like in the form of standard views, secure views, and the materialized views. And stages are available as like either table stage, user stage. Mostly what happens is like whenever we create a table, the table stage will be provided automatically. It is an internal stage available for us. And the user stage is also if I create a user for my name, or like my friend's name or Shrikant name, so like that. So we do have users created for the team, right? So in that scenario, we will get the user stage created automatically. But if we can create the external stages or like the named stages explicitly. So whenever we have a file in our local and we want to load it into the system, we can use these stages and have the data available in the stage, and then we load it into the corresponding tables. So also we do have objects available in the form of file format. So we will be having like XML, JSON, Parquet, all these formats, right? So these are supported here. And we do have object of like sequences, which will be helpful for the creation of the sequence and or like surrogate keys and all these things. And Snowflake has support for stored procedures and user defined functions also. So this is more similar to the existing SQL systems, and I'll be covering the detailed features of these things. So the first one I want to cover here is like standard and the extended SQL support. So as part of this, if you see, it is like more familiar to the persons who is working on SQL. So Snowflake supports ANSI SQL support. So any data analyst who has knowledge of SQL, or any data engineer who has knowledge of SQL, can directly start working on it without much hassle. So the core data types supported here are just like other databases: int, float, char, string, boolean, date, timestamp. And there are complex data types which are like variant, object, and array, which supports the nested level of data, etc. So column level constraints also supported here, like primary foreign keys, and then the unique constraint and not null constraints are available. Information schema is available for us to have all the metadata maintained in the system for all the queries we run, or for all the objects we create, for all the columns which we maintain in our tables. So all object level metadata or all account level metadata, including billing and all. So all these things will be stored in the information schema. So which we can use to understand and verify, like validate the things accordingly. And transactions are supported here, like in the form of auto commit and rollback. Resource locking is possible, and advanced DML statements are supported, like insert, update, delete. Multi-table inserts are there, conditional inserts are there, and merge statement is available. Windows functions like rank and all these things we have like available for the usage purposes. Statistical aggregates are supported, stored procedures are supported, user-defined functions in the form of like SQL or JavaScript-based ones are supported. And if we have a hierarchical data, like we have different levels like parent, child, and then the next level. So if we have to maintain those levels in Spark and all, we don't have them readily available. We have to use different type of concepts to implement them, right? So Snowflake has provided it internally. So we can use the connect by class to use those things. So coming to the data loading to the Snowflake. So if we have to load the data into the Snowflake, we have different ways. So first one I want to start with is my like local file system. So I have my C drive or D drive, or like if I'm using Linux machine, I have some files in my local. So I can load those files into the internal stage of Snowflake using the put command. So I'll be like putting use the command put and then the d colon the file name, and then just I'll give the stage name. I'll create the internal stage before loading it, so the data will be available into the internal stage. And then after that I can use the copy command, like copy the corresponding data from the stage into the table. So my table will be loaded with this data and it is available for the querying purposes. So similarly, if my data is in not in local file system and it is in like external cloud, maybe like GCP, Azure, or AWS, so then I can create an external storage, external stage, and I should create the storage integration here. So the storage integration will be to access the cloud data, like if it is in S3 or like if it is in Azure. I need to have the integration created to access the data from those cloud storage, and then I can use the same copy command directly from the stage, external stage, into our table. If time permits, I'll be able to show that towards the end of the session. So once the data is again available in the table, we can start using it as part of our processing purpose in the further layers once the data is available. So next, the third one is like kind of continuous loading. So we have continuous data being loaded into some particular location. So we can have different queuing mechanisms which are available as part of AWS, GCP, or like Azure. We can use those, and we can have a snow pipe created which will try to connect to that location where the files are coming in, or like the queue where the files are coming in. We can integrate it and we can start continuously reading the data. As soon as the file is available there, or as soon as the data is available there, Snowpipe will copy that into the tables. So here there is no need for us to create any virtual warehouse. Snowpipe will be taking care of that. So that provisioning will be done internally by the Snowpipe, but there will be extra charges or like extra billing for the Snowpipe usage. It is like out of what we use. So moving to the next level. So as I said, right, different file formats are supported here. So Snowflake actually supports this batch loading, continuous loading, and unloading of data also into the other tables. So file formats are CSV, JSON, Avro, ORC, Parquet, and XML formats. And compression is supported in the form of Snappy or like JEtlib. Snappy compression is mainly for the Avro, ORC, and Parquet, and JEtlib is for the ORC. So as I said, staging, we do have internal stages where the data will be loaded into the Snowflake and the data will be maintained internally in the Snowflake only. And we will create external stages for this Amazon S3, Google Cloud Storage, and the Microsoft Azure Blob Storage. So the command I have mentioned, right? So to use the copy command, we can do like this: copy into my table, and from this @ symbol we will use, or like @ symbol we use for the stages, different types of stages. So here whatever the my external stage, this is an external stage created already, like create external stage, and the corresponding command we will be giving the integration details and all. So we will take the files, we can filter the files whatever we want to load into the table. Those stage contains much more data, we can only select the small set of it and we can load it into the table. Okay, so continuous data loading from the files, we can use Snowpipe to load these micro batches of data, just like Spark. And micro batch source, it can be available in the form of internal stage, or it can be in the form of the external stage. So as I said, there is no need to like upfront create some warehouse, virtual warehouse or something like that. Snowflake internally provides these and manages these compute resources needed for this Snowpipe to be operated. So how can we access this data? So to explain this, we do have Snowflake web-based UI. Whenever we create this account, we will get this option to log in from the web UI. And we do have SnowSQL, which is similar to the command line clients we have available. And also we do have multiple partner connects available in the form of ingestion, ETL, or like business intelligence partners are available. And we do have data analytics partners, and then the security and the governance partners. So all these things I'll be covering in the later slide. And we do have connectors and the drivers available. So like if you want to connect to the Snowflake from Spark, and if you want to connect from Python and work on this data, it is possible using these connectors which are provided already. And ODBC and JDBC connectivity is also there. And we can integrate this with the Apache Hive Metastore. So it will be helpful if you want to use it as Hive Metastore in the form of when we are using with the existing things. Okay. So the next part is the change data capture, which is the major thing in our warehouse usage. like we will be using slowly changing dimensions also to capture the changing data. So here streams is a concept which simplifies the usage of change data capture. So what happens is, like, whenever we create an object, stream object, it will try to capture what all the changes are happening in those tables. Like if it is having inserts, it will try to maintain the data. If it is like having updates, it will have that metadata maintained, and if there is a record being deleted, that data is also maintained. So only the stream contains the metadata, not exact data. So like if we see, right, so it does not maintain any data which is changed. It's just try to capture that particular offset and what all the changes are happening. And then when we apply this stream onto a table, all these changes will be applied onto that. Okay, so it is actually done based on the versioning history maintained in the table. So Snowflake maintains the history in the form of versions, right? So that particular data will be applied onto the target table. So all these, if I have a table which is being changed continuously, so all those things can be reflected onto the target table using the streams concept. So tables, stream tables are like of two types. So one is like a standard stable stream, which will track all the DML changes like inserts, updates, and deletes, everything. And append only table stream, it tracks only the inserts. So if you want to only just capture like my data is of type only appending, so then we can use this stream. So I'm moving to the data sharing concept. So as I said, right, data sharing is a major thing in the world of this data engineering, right? So what happens is, like, if I have a provider account, like I am the provider, so I have different types of tables, views, and all these things created. So I can share this particular view with another account, and that account can start querying this data in the read-only mode, and the charges only will be for their processing power or the compute power, not for the data stored, because data is already in Snowflake and it is being maintained and maintained and paid by the provider. So consumer account will be only charged for the warehouse provisioning and processing. Okay, so one constraint here is, like, both should be belonging to the same region when we have to share this data. So this is the one constraint, and the access will be read-only access. Moving to the next one, backup and the recovery, and also the data replication part, which is the major thing for us. So in the world of data, so like the recent services which we are getting in the form of different clouds like BigQuery, or if we take Databricks, or like any recent warehouses or like lake houses, they are provisioning us the functionality of time travel, which will be like having the versioning in the backend. It will enable us to go back in time and query the data. So due to some reason, if my data is gone, I can go back and I can query that data, or like somebody updated the tables by mistake and I want to go back to the previous state of it, so I can travel back using the commands available, and I can get those particular records which are corrupted or like which are changed. Unwanted changes can be recovered. So time travel is option which enables us accessing the historical data that has been changed or deleted at any point. So querying, restoring historical data is like possible for the databases, schemas, and the tables. And data retention period can be configured at any object level. So while creating the objects, or like while having them created, so we can give the correct corresponding data retention period based on the type of edition we will be using. Like Snowflake has different types of editions available, like standard edition, enterprise edition, and then we do have virtual private Snowflake edition. So for these different editions, it will be like provided based on the type. So to use this time travel, we will be having extra storage costs because we have to maintain the multiple version of data. So if we are using Snowflake standard edition, the time travel option provides us 1 day to go back. And then if we are using enterprise edition, we can configure it from 1 day to 90 days. So if I select a Snowflake enterprise edition, I will have the ability to choose it to go back till 30 days or 10 days based on my system requirements, or like the way we configure our data warehouse. Okay, so time travel will allow us, but due to some reasons my complete Snowflake system is down. So then there is a concept called as failsafe. So what happens is, like, it will provide us the ability to get the data back in case of like some system failure or any other big disaster events happening. Okay, so in that scenario, we can reach out to the Snowflake support team, and they have the ability to go back for 7 days out of this time travel thing, excluding this 90 days or like the 1 day we configure. So it will go back for 7 days, and within the 7 days it is able to recover. And if the event happened and 7 days are crossed, then they are not able to recover this data. Okay, so like if we take anything, if we have a timetable and time travel enabled for 30 days, so 30 days plus 7 days failsafe period will be available for us to get this data. Okay, so Snowflake support team need to be involved for this, and accordingly, based on our like 7 days period, we will be able to get that. Okay, so database replication is also supported. One major thing is like, as Snowflake is available on multiple clouds, right? So we can have this replication done on multiple cloud platforms and across regions and across availability zones and all this. So if you see here, we can replicate data across the Snowflake accounts, as I said, and then the regions and cloud platforms. I'll be covering the slide which will depict this cloud platform scenario. And here the replication is available at database object level also, and it supports the disaster recovery functionality for us. Okay, so moving. So these are the different types of tables available and how we can recover these things. So if my table is of type temporary, so it will be available till the remainder of the session. So till the end of the session it is available, and it doesn't support cloning option. And time travel is either 0 or 1, and failsafe period is 0 for these temporary tables. And in case of transient tables, until we explicitly drop the data, the table will be available, and it supports cloning. And also time travel retention period is like 0 or 1 for this, and failsafe period is 0. So temporary and transient doesn't support the failsafe period here. But when it comes to the permanent tables, if we take standard edition and enterprise edition, or like virtual private Snowflake edition, so these tables will be like completely available until we explicitly drop them. And this supports the cloning. Okay, so cloning is also one important thing, which is like a kind of having zero copy concept. I'll explain it towards the end. And time travel redemption for this standard edition table is 0 or 1, as we discussed, and failsafe period will be 7. So we can get 8 days in case of standard edition to get the data if it is corrupted or if any failover occurs, something like that. In case of enterprise edition, so if we configure it as 90, then we'll have a failsafe period of 7 days, and we can get the data back going back to 97 days. Okay, so we'll have coverage of 97. Okay, so moving to the next one. This is related to the data replication across regions and the cloud platform. So if you see AWS Snowflake account, it is present in the US West region, and the primary database is in the like provider account 1, and consumers are in different regions. So the data is shared with two consumers, consumer A and consumer B. So for the usage purpose, this database is replicated onto the Azure East US2 region. So automatically region level coverage is also there, and also the cloud level. Like if due to some reason my AWS cloud is also down and the service is not available for 1 day or something like that, then Azure can start providing that. So this way it is like a kind of better option if you want to have the data replication across different cloud platforms and different regions. Okay, so as I said, right, Snowflake has a good partner connect, and it supports different rich partner connect, as I said. So if you see data integration, we do have IBM Data Stage, Informatica, Talend, Stitch, Stream, SnapLogic, Trifacta. All the major data integration tools can be easily connected with Snowflake and have the data loaded or like take the data. So the integration is easy with the Snowflake, as they already provided the connectivity. And when it comes to the business intelligence, like creation of the reports or like having the data provided in the form of cubes, or like having it presented for the management and all, we can use the different types of tools like Power BI, Tableau, Looker, Click, and all these things, right? So this integration is already available. And for the advanced analytics purposes also, like Databricks, Kubol, SAS, Spark, and all these things have already connectivity established. And security and governance is possible through Colibra, which is like a metadata processing. And then we have Informatica available, Alation is available for that. And from the SQL editor's perspective, as I said, we have a UI provided by Snowflake itself in the form of web link, and SnowSQL from the command line perspective, and dbeaver SQL workbench, which are third-party ones. We can use those also to connect to the Snowflake and query the data. And from the programmatic interface perspective, we do have Python. So from Python, we can connect to Snowflake easily and query the data, like update the data accordingly based on the needs. And SQL Alchemy connectivity is there: Node.js, Go, Spark, .NET, JDBC, ODBC. So this is like a kind of rich partner connect which Snowflake has. And before moving to the benefits, so like who are the competitors of Snowflake? So like in market, when Snowflake is introduced, like it like started capturing the market, and like Google Cloud also has its own version of it, like we call it as the BigQuery, and Databricks also has introduced this Databricks SQL recently, though Databricks is present in the form of data lake or data engineering world. So now both the ends got connected from the form of data warehousing and the data lakes, and now Databricks providing it as a lake house completely with Databricks SQL and the generic version of the Databricks. And Snowflake also started with this warehouses, and also the Snowpark connectivity is also provided, so that this also can act as a lake house. And GCP has provided us the big lake, which will be providing again the lake house concept for us, integrating both the data warehousing and the data lake. And AWS, and then Azure, all these people are like moving towards with their services provided. Okay, so the direct I can say like the comparison or the benchmarking is being happening on Snowflake and Databricks mainly, and they are like kind of competing in this world with their own major features provided to us. Okay, so what are the benefits we will get by using the Snowflake? So it provides the modern security. It always has kind of always on encryption to keep your data watertight, and it is perfect for sectors like where we have like sensitive data, like banking, financial services, or like any other things which deals with this main security data. So it is one of the things which automatically supports, and this benefit we can get. And advanced analytics, we want to do some different types of analytics on like stagnant data or like real-time data streams. We can like provide the analytics in secured manner and governed manner. So high scalability perspective, as I said, Snowflake supports like unlimited number of workloads. By providing the compute power, we can just spin up the clusters on top of the data, and we can query it whenever we want. Very powerful machine, it is available like in the form of, as I said, t-shirt sizes, small, extra small, medium, large, XL, double XL. So like the power of these compute warehouses are also being increased in each and every version, or like with every release. So they are providing the more needed things based on the kind of workloads. Okay, and as I said, from the easy manageability perspective, uh, Snowflake like comes up with automatic provisioning of these warehouses and all. There is nothing we have to look at from the infrastructure side, or like we just have to design our warehouse, go ahead, load the data, and just start using it. There is nothing like optimization and all you have to do. So if you have to do the optimization also, or like clustering and all these things, you want to look at based on the type of distribution of data, like the what I can say, skewness and all. So then you should have around 1 terabyte data. Then you can go ahead and look into the clustering concepts and all. Otherwise, Snowflake will be taking care of these things. And also, they will provide the plan for these queries which are running. So this is like completely manageable, and strong accessibility is there. Like you can get the 24/7 access from everywhere, like anywhere from the world. You can easily access it. And what are the different types of use cases it supports? Like we can use it as a like a kind of low cost storage, just like other cloud services we do have, right? So we can have the data loaded and we can start querying on it. Okay, and we can have reports created on this data. So generally data warehouses enable multiple teams to create their reports on top of it. So because of the support, the transaction support and everything we do have, and also the analytical support we do have in this Snowflake, we can directly connect to it, and we can start providing the users quickly with faster provisioning to the users. Okay, and analytics, if we want to do some analytics, or like we want to provide some insights, or like we want to provide some trained models and all, we can use Snowflake for the provisioning of this data, like in the form of analytics or in the form of AI and ML processing. So it supports automatically. So these are the type of use cases we can use for maintaining the data and providing the users better experience. So coming to the best practices, so whenever we create these virtual warehouses, we can either set the auto resume and auto suspend. What happens is, like, when we enable the auto suspend, if you are not using the warehouse for 5 minutes or 10 minutes, it can get auto suspended. And whenever we run the query again from the worksheets and all, it will start the warehouse for us. Okay. And remove unused tables in the warehouses, because like whenever we create some tables, right, so it is for temporary purposes, something like that, and if we leave them, the cost will be added, right? So better thing is, like, if we don't want any tables, we can better drop them. Okay. So we are sure, like, if this is not being queried for a large number of days, or like, we can check those things, we can have those audits added, and accordingly we can maintain our system better. Okay. So it's always a good practice to remove the tables which we don't use, or like the intermediate tables and all we create for the temporary purposes. Okay. And caching is one more feature which Snowflake provides. So it is at the level of results, and also local disk cache is available and remote disk cache is available. So your cluster is a persistent cluster, then there is not much benefit we'll be getting. If it is not a persistent cluster, then we will not be getting much benefit out of this. But if you are using a persistent cluster, and if it is like we are running a query, and my teammate also querying the same data, so he can get the data from the result cache. So the result cache will be available for 24 hours, and no processing charges will be there for the data which we are fetching from the result cache. Okay. So this way it will try to give you the better costing things, also billing perspective. So we can use the cache to leverage the already existing results. If we already queried some huge table and we got the output, so that data we can rerun it or like requery it multiple times, but without any charge. Okay. So these are available across Snowflake's independent virtual warehouses, and query results returned to the one user are available to anyone else also, like as I said. So other users also can get the same result cache based data when the other user is querying it. Okay. And Snowflake query profile will help you to identify what all the bottlenecks we have for the performance. And using this query profile tool, we can diagnose the slow running queries and we can modify them accordingly. Most of the times, as I said, optimization will be happening internally based on the data stored and all. But if we have some corner cases and all, so we can use this Snowflake query profile tool, and we can provide the details. Okay. And auto scaling, as I said, right, if we are using like different versions of the Snowflake, multi-cluster warehouses are available in the enterprise edition. So these will be configured like I can say that, okay, my query is taking long time and I want to go to this much power, like Excel power, or like I want to have four clusters running. So we can configure that, and based on the need of the resource hungry query you are running, or like load you are running, it will enable those clusters to run and automatically downscaled when it is not needed. Okay. So this auto scaling will help us a lot. We do have, as I said, scale up concept is there, scale out concept is there. And if you are using enterprise edition, we have multi-cluster warehouses which will support to automatically query these things, automatically started and stopped based on the configurations we do. Okay. So coming to the upcoming features, Snowflake generally provides us the new features continuously, like every month or like based on their release cycle. So based on the last updates, what I see is like Snowpark optimized warehouses are like in preview, and once these things are like completely tested and used by the users, they will be available for the users completely in the form of GA, generally available for the, like I can say, completely available for the users. So new warehouse option provides 16x memory and then 10x cache compared to the existing warehouses for in this scenario. And they're also providing the support for the tables with masking policies and the row access policies from the security perspective, or like provisioning access to the users, or like providing the data in the form of masking. So these things are in preview, and they will be added as a complete features in the upcoming days. And database replication is available, as I said. So they are adding the support to streams and tasks also. So we discussed on the streams. Tasks are like for the orchestration purpose, Snowflake internally provides the tasks for us, and we can create the tasks to run and schedule them accordingly. Okay, so account replication UI. So like if you want to do the account replication at account level, so then we can use this replication UI. Again, this is still in preview phase. So in upcoming days, it will be converted to the full feature. And column lineage in the access history. So like whatever the tables we are querying, the corresponding source columns and the corresponding source related objects, we can track the complete lineage of it, or like the column lineage using this access history. So this feature is also currently in preview. And data dictionaries for the Snowflake marketplace listings is also available. So like wherever we need the data dictionaries, like for the different domains and all, so we can use these things which are provided out of box from the Snowflake. Okay, so coming to the limitations, like before we used to have limitation of maintaining the unstructured data when Snowpark and other things were not introduced. So it is like kind of acting as a cloud warehouse only. Later, like as I said, with the introduction of the support for the unstructured data and all, it became like lake house, which takes all the data, which can maintain it. So but now there is like kind of no data constraint. So like if I want to load the data, as there is no limit that this much data only you can store on the Snowflake, you can load a number of files, something like that, and it will end up with like huge amount of billing for us. Okay, so because of this no data constraint, sometimes we end up with major billings and all. And no on-premise option is available. As I said, Snowflake is like a software as a service, so we can directly use it from web as a service, but not in the form of on-premise cluster or like on-premise service. Okay, so price escalations happen in few cases generally. So if we don't do the capacity planning or like the designing perspective, and we don't do the POCs, or like generally we do that, but in some scenarios what happens is like we try to use the standard in times of like when we are doing the POCs and all. But when we go ahead with usage of enterprise clusters and all, so there will be different cost changes, and that end up with we will be paying more as compared to the like existing scenarios or like the use cases we checked. Okay, so also compared to the Google or like AWS Redshift and all, the community is also less if we compare it with respect to the existing major cloud users and all. So it is small community, and this is one limitation. And before going to the I think I do have a few minutes. Just I want to quickly show one thing from the demo perspective. I just want to show like whenever we want to create the Snowflake, we can go ahead and have the Snowflake account created. And as I said, right, so we will be provided with the details. So my account details are like JDA30064, and the region is like centralindia.azure. So I can use these things. This is the UI. So we can use this UI to query the data. We can go back and start using it. So this is sorry, one second. So these are the worksheets we do have. I can query the data from the databases. So I can go ahead and create the corresponding objects for me. Like I can create the tables, I can create the views, I can create the schemas. And if I go into this data concepts, if I go into my corresponding database, I can have the corresponding schema created here, corresponding tables created here, and different types of roles created here. So we can go ahead and use these options from the UI. And we do have a similarly SnowSQL available here. So we can connect to this SnowSQL. We can have it installed. We can connect to this JDA30064 centralindia.azure, and I can log in as my user. And after that, just like general SQL, we can use the database and the schema. We can show the tables. We can create the tables. Okay, just like create or replace table, the columns, and then the format we want to store the data. And then we can query the tables. Also, as I said, right, the tables come with its internal stages. So if you see @% we can use it for the table stages. So directly I'm putting my local file, which is in my local machine. I'm putting this file into the table. Okay, so this is available in the stage now. And after that, when I run this copy command into this table, so automatically the data will be loaded, and I can query the data from the corresponding tables. Okay, So here, if I remove this @% I'm directly querying from the table. So the data is already loaded and is giving me the data. Okay. So that's all from my end. And coming back to presentation mode, I think I hand over it for the question and answers.
Sorry, I was muted. Yeah. Let's move to questions. We have them from our audience. So first question is, what is it? Yeah. Is there any difference or restrictions for Snowflake between cloud providers? Maybe some features are unavailable or something else?
Yes. So
No.
like as I said, right, it is continuously improving its services. So few services are not there in the initial days, and with every feature they are adding the support. So like now we see like data replication concept, it is not there for the streams and tasks, right? So then it is like adding it in the next phases. And Snowpark was not there in the initial days, which provides the support for the users. And now it is being added, it's in public preview. And unstructured data support was not there. So like I can say it is continuously evolving, and in the same way the other cloud providers are also continuously improving based on the features it has. Like one cloud is providing one service, so the other people are slowly replicating that, like from the BigQuery or like Big Lake perspective or like Databricks perspective or Snowflake perspective, they are coming with their best versions and providing it as a service. Then the other people also started using those services.
So yeah, based on your experience, what's the most fresh Snowflake version on which cloud provider? So you're using
So,
Azure?
so like I can say like Snowflake is provided as a service, right? So as a users, based on the need, we can take the Azure. Like generally, most of the times I use Azure recent days, and initially we use GCP. So GCP came into the field very late, and it doesn't have all the features supported in the initial days. So in that scenarios, whenever there are restrictions, we used to like decide on the features we need. Like when we are doing this planning and all, we need to see like what exactly we need. So like we are going for the GCP, but this event processing is available there or not for the, like the, if I'm using AWS, Kinesis support is there and to what level it is supporting. So that kind of research we have to do based on the functionality, and then we have to go ahead and use it. So from the versions perspective, like the SnowSQL and all, I do have the versions available, but this is a, as I said, right, software as a service feature. So there is no concept of versioning and all. Like if we take the software like SnowSQL and all, we do have versions available, and we can use them for our integration purposes or like the querying purposes.
Mhm. Okay, yeah, we also have a question from Oleg. Yeah, so what's the reason of using Snowflake over GCP, taking account that GCP itself has all the components that Snowflake propose?
Yes. So generally, if we have to go quick to the market, like when we started, my personal experience is like when we started with the implementations and all. So if we have to go quick to the market with the help of Snowflake, it is providing the better billing in few aspects. So like Databricks is good in one aspect, like when our workload is of one type, and when we do this comparison and the benchmarking, few scenarios Snowflake is good. Like from the data warehouse perspective, GCP is providing us the BigQuery. Okay, and from like Databricks perspective, if we take, right, so it do has its programmatic interfacing and all. It's very strong in its aspect. So based on our workload, we need to do the like whenever we want to use the service, right? So being an architect, I'll be like trying to do the POC. I will see like based on my workload, my current system, or like if I'm migrating from the existing system, I will do the benchmarking and I will connect with the corresponding providers. I will see like which one will be giving me the best benefits for my requirements. So in our implementations, we did the same thing. So like we reached to the like Google team, we implemented a POC on it, and then we went to the Snowflake people. We took a POC and we see the comparison, like the benchmarking, with the POCs, and then we will go ahead and start using it. So from the features perspective, they will be having a number of features, but for my requirement, it depends on how I want to like how as a team or like how as an architect, how I will be proceeding further. So
Mhm.
how much benefit I'll be getting out of the usage. So in most of the factors, for our implementations, Snowflake like did better compared to the existing legacy things, and then Databricks SQL also came into the existence and it also performed better. So based on the again the existing platforms, we chose the
Mhm.
corresponding ones.
Yeah, we have some also related question. Can you compare Snowflake and Delta Lake? So maybe you have
Yeah.
the
So
experience.
Snowflake, as I said, right. So before we used to call it as like a kind of data warehouse because it supports the SQL mainly, right? So in the later phases, with the introduction of Snowpark, like integrating it with the IDEs, and we can use it from the different programming languages directly. It provides just like Databricks. So what I can say is like now it has the ability to provide the data lake concept and then the data warehouse concept. So it supports all the things inbuilt now. So we can have a unified lake houses just like Databricks, and we can process them here. So when we want to use data lake, mostly we will go for like AI ML workloads or the real-time streaming data or like the batch processing. So all those things are supported on Snowflake. So Snowflake evolved from a cloud I can say cloud warehouse into cloud data platform, and now like lake house, which is supporting all the workloads. So in my first slide itself, I have mentioned like when we take the data warehouse mainly focuses on providing the business intelligence support in the form of SQL uh, without having support for the unstructured data and all. So as I said, it doesn't support in the initial days, but slowly with the features being added, now it is supporting all these things, and it evolved to be a lake house which is supporting the both the features, both the best features, supporting the AI projects, providing like support to the ML projects and all these things.
Also have a question. Do you know if how can Snowflake read directly from Kafka stream?
So right, okay. So I have shown you the slides. How can we load the data, right? So when we are loading the data, we do have a concept of Snowpipe. So we can integrate it based on the like if it is AWS Kinesis, if it is Kafka, or if it is like GCP PubSub or like Azure Event Hub. So that integration is available, but to what level we can see, and then we can implement it from the support perspective. It do support the real time data, but it will be loaded into the Snowflake, and again the processing power we need, we can have the warehouses providing the data for the reporting purposes. So like if I want the real-time report, definitely it will not be a kind of pure real-time just like Apache Storm and all supports, right? It's not always. It is like a kind of micro batching based only, but this Snowpipe streams concepts enable it to read the data from like the event data either
Mm.
from Kafka or either from the Kinesis or the PubSub and all. We can integrate it, and then we can have it like available to the near real time, just like other services too.
Mm-hmm. So also have question about uh, Snowflake cost of storage low, almost as pure S3, plus all power of a full SQL. Plus no, it's not a question. Sorry, it's just a opinion of Ivan. Yeah, thank
Okay.
you. Also, we have. Let me check. Is there a replacement of Delta Life tables in Snowflake?
Sorry, can you repeat that?
Yeah, we also can open our platform StreamYard and see this question.
Okay,
Sure.
sorry. Yep. So like if we talk from the Databricks SQL perspective, right? So the way it is implemented is we do have the concept of delta tables and having them scheduled like using autoloader, or like we can have these things scheduled based on the data we will be getting. So continuously we'll have the data loaded using autoloader and have these delta live tables processed, right? So in Snowflake, we do have the concept of streams and then the tasks, but like from the exact comparison perspective, we need to just check it and get back on that. So I'll try to revert on this accordingly.
Yeah, and also question from me. Maybe you can suggest some websites or materials or books how to learn where I can learn the Snowflake
Yes.
deeper.
So like if we are from EPAM, right, so we do have internal trainings available, right? So using our learn portal, we can go ahead and register for the courses, and Snowflake has its good resources for the training, and we can register for that, and we can go for the certification Snowpro Core and the corresponding data engineer certifications and all. But if we are external users, also we can go to the learn.snowflake.com, and whatever I have explained, right? So the practical implementation of these things are available. We can register for the data warehousing or like the corresponding data engineering courses, and then we can continue the course to complete the end-to-end suggestions of it, and then we can go for the Snowpro Core certification, which will make us be ready for the implementations or like making us stand out as part of the process. So mainly, yes, if you do have any questions, you can reach out to me in my LinkedIn, and I can be able to help you out with the further studies or some POCs if you want to go ahead further. So this will be helping you to do some POCs, or maybe like if you want to excel in this area along with
Yeah.
Databricks and all.
Yeah, thank you very much, Shidhar, for this interesting topic. Yeah, Snowflake is very popular. So yeah, thank you very much. We will have next talk in 13 minutes, and Nikolay will talk everything about data science, its power and its weakness. So stay tuned. Yeah, thank you. See you
Thank
soon.
you all. See you soon.
Hello everyone. It is Winter Data Meetup from Zen Community. Our speaker is Nikolay Kurbatov, and he will tell us the whole truth about data science, about its power and weakness, what it can and what it can't. Please don't hesitate to ask your questions in YouTube chat. Hi Nikolay, it's so nice to see you here. The floor is yours.
Hello everyone, thank you so much for joining me today. So hopefully this talk will be beneficial for at least most of you. So without further ado, let's start. So my name is Nikolay. I've been with EPAM for about 2 years now. And today I will present solving data science business challenges. Actually within 7 big challenges which I have been facing throughout my career before and at EPAM as well. And the agenda would be the following. So first we will discuss what the data science is about, then briefly cover the difference between data science and software engineering. Then, as I said, we will discuss these challenges from 1 to 7. Then key points, actually the most important slide is key points. I would really encourage you to save it or make screenshots. And then, of course, question and answer section. So let's move forward. All right, what is data science? Well, as you can see on this Venn diagram, data science is an interdisciplinary field that connects computer science, math and statistics, domain and business knowledge. Also, we cannot discard software development and as well as traditional research. So that is the reason why if you will Google what data science is, or probably ask ChatGPT, right, you will see lots and lots of different answers. But the main idea is that will always is, and I think be, an interdisciplinary field which connects a lots of other fields. So, and yeah, so okay, so data sciences doesn't equal software engineering, although it cannot live, to my mind, without it. And the difference between data science and software engineering projects could be very substantial. So, for example, data science project cannot live without the data, in contrast with software engineering, because you can literally start without any data whatsoever, speaking about software engineering. Also, data science project focuses on exploration and discovery, such as probably heard that before, finding an insight in the data, identifying data sources which could be used for the model training and so on. And then also important part about data science project which distinguishes it to software engineering is domain focus, because project which is powered by data science in healthcare would be vastly different to the project which is powered by data science in automotive industry, in retail, or any other. That's why, as I pointed out before, domain expertise is a part of the data science as well. And also, one of the important part is that data science cannot be, as I said, think without data, but it also connects with the code. In contrast, software engineering, projects are heavily code oriented. So this is, it's not, of course, the full list of the differences, but to my mind, this, brief 3 parts on one point and 3 parts on the another should give you a brief overview of how they differ. So actually, that's also very important and very interesting figure. I think right now it's probably the same. So unfortunately, approximately 80% of all data science projects never make it to production due to not only the challenges which I will tell you today about, but also due to some other difficulties. But basically, numbers are not so good. They're kind of progressing towards less drastic number than 80%, but still, unfortunately, number of projects which make it to production is relatively low, and we are actually at EPAM working to increase that number to make it much more better. So, all right, now speaking about the challenges. So, challenge number 1, simple, right? Business hypothesis first, and sounds simple, but unfortunately, it's not. So, I have encountered a couple of projects that has been starting the task using the data, meaning that they start solving the task using data without any hypothesis whatsoever. I mean, business one, which actually could be translated into, having a baggage, collecting a baggage, packing the baggage to go to vacation, for example, but without specifying to which location you will go. So if you go to Hawaii, that would be one type of package, right? If you go to Alaska, completely different, right? So that's kind of a very bad and ugly analogy, but still works for most of the cases. And actually, there is a solution to that. It's quite simple. You start and validate the hypothesis first, and then you look for the data which will prove that the task is actually solvable. So to my mind, that's the first and not foremost, but the first thing which is quite easy to start to and easy to actually solve with the correct approach. Second problem is that one size fits all. So here, there is a kind of misunderstanding that there is one, golden algorithm which will rule them all, or which will solve everything, which is unfortunately not true. So there is no magic algorithm, and the solution to that is an algorithm is just a tool which should be tailored to the business hypothesis at hand. meaning that each business hypothesis, like, has, its unique requirements. Hence, you have to choose a tool, meaning algorithm, accordingly. And probably one additional, piece of advice is to probably use Ensemble as a stack of algorithms used. But basically, yeah, that's the one. So third one, as I started regarding the data on the second slide, the data is vital. Lack of data to solve, and there are lots of issues. Then there is actually you for example, you have completed the business hypothesis well, but then you stumbled upon that there is no enough data to prove that this hypothesis could be solved through the data science. So, and for data for the data science kind of a fuel for the cars. So without fuel, your car couldn't ride. Neither data science project could be succeeded. So, and the potential solution to that is to start the data analysis task before the actual development, so that the team of data scientists will actually understand which data source they will use, and within that source, if the data presented is enough. That's important. Now, okay, business versus technology, challenge number 4. So here, there are sometimes there is a misunderstanding between business metrics versus data science metrics. It means that while developing data science models, the development team or data science team could focus more on statistics, math, you name it, evaluation metrics of the model, which rather than business one. And that actually this solution to that problem is, to my mind, probably in the top 3 of the ones in terms of the efforts to be solved. So they are this problem is very hard to solve, unfortunately, because sometimes there is no direct way how to map model results, model evaluation metrics such as ROCALC, F1 score, accuracy, whatever you name it, to, for example, churn rate, right, a business metric, or average revenue per user, or any other metric you can think about it. And potential solution to that is to use business metrics for the model evaluation when possible, and in other cases use proxy metrics. And actually that task, to find the proxy metric is, as I said, one of the most challenging tasks for any data science product owner, product manager, as well as any data scientist in the team as well. So yeah, I would encourage you to look very detailedly into that challenge as well as others, but this one could potentially pose a lot of difficulties along the ride. So next one is probably obvious, infrastructure, right? So there are numerous cases I've been encountered. Then there were lack of infrastructure. I mean, specifically data science infrastructure, right? Data science infrastructure, should be in place to run a model on real data, and without it, and without this infrastructure, model still could be deployed, but the cost of maintenance for the development team could be very high. So basically, the potential solution to that is to design data science infrastructure after the business hypothesis and data steps have been solved, meaning that business hypothesis has been taken into account, has been written down by the product owner or product manager, then data which is sufficient to prove that this business hypothesis could be solved has been found, has been labeled if needed, right? And then this task could be done in chunks as per priorities as well. So next one is communication. Gap in communication between teams is very much a real problem, because business and development teams oftentimes speak different language, and that's perfectly fine. Not fine, then there are unrealistic expectations from the development team and failure to deliver due to technical constraints in the business context. The solution to that is also could be look like pretty simple. Data science projects should have clear roles. Also, I mean, by clear roles, I mean there should be definition between MLE, which is machine learning engineers, data scientists, data science product owner as well, and business stakeholders should receive communication in a business context, not a technical one. That's very important, because if you will do the business stakeholders, kind of messages in terms of, okay, we have received our ROCALC score equals to something, it will mean probably nothing to them. So you have to adjust your communication to the team members as well. That's like all about communication. And yeah, challenge number 7 is future planning. Sometimes there are no plans of how data science project will live on production, and the lack of goal life roadmap for data science project could result actually in a wasting of development teams' resources in the long run. Well, it almost always does. So the potential solution to that is to have a clear vision after the go live phase, not just development, and also the vision how could data science project could be adjusted according to the market challenges. For example, retailers who had been trained the models before COVID probably were very, they were very fascinated by the absolutely different patterns of users within COVID times, right? So that's one, example to that. So I have to adjust. And yeah, so as I said, this is slide 11 already. Key points to remember from back. There are just only 4 of them. So first one is data science projects should be realistic. They should pursue clear goal. This is what I mean by realistic, right? Then projects should bring a meaningful business value. And the most important part, you should understand how to measure this value, right? Out of the data science project. Again, data science projects should be simple. In parentheses, I put that ideally, because unfortunately in real life it's probably not always the case, but it's a good exercise to start simple, to start using, to start from simple models and then to progress further. And data science should not be considered as one-time activity, as I stated in the previous slide. So yeah, I mean, 12 slides, 15 minutes. So I think I'm even almost on the time. So yeah, that's pretty much it, guys. I would love to answer questions if you have any.
Looks like we don't have a lot of questions in our YouTube channel. However, some questions appear. Does all these parts relate to all data science projects or only difficult ones, like autopilot? To all
yeah, like autopilot, you're probably referring to maybe Tesla, right? But I'm not sure. So short answer is to all data science projects. The more longer version of this answer, that depends on the project, because sometimes, not always all of these 7 challenges I apply. Sometimes only a couple of them apply because, for example, data science infrastructure is in place or communication channels are working fine. But basically, this kind of, an aggregation of the most common problems I was able to identify. But I really think this is not the whole list. I mean, this list could be really, really, really long. But those, if you will do your best to avoid like all the 7 challenges, the chances you will be here could be less. I cannot like promise it, because you never promise in data science, right? But the chances could be less. That's an idea.
Those numbers are astonishing. I never realized it. Like 80%. Wow.
Unfortunately, yeah. Unfortunately, it is.
And if you're talking more about project with data science, what do you think? Software development projects and data projects, are their teams different? I mean, in the numbers of developers, QAs, business analysis. What are the specific
good question, actually. Yeah, very good question. So I think about this, data science project could not be done siloed just by data scientists. Data scientists must communicate with the engineers, whether they want it or not, because if they will do all by themselves, training model for a couple of months, then trying to push it to engineering will struggle. So basically, one of the essence and the potential challenge, as I point out, communication. And I have watched numerous examples when teams were siloed, meaning data scientists on stand-up telling what they have been done, what they will be doing, right? And now everybody listen to them, and nobody pay attention because, okay, they're doing something very strange. We don't understand the value of this team, right? And then suddenly, after 6 months of development, they give some kind of a model to engineering so that engineering could put it into production. And here chaos came, because that will bring a lot of effort, that will require, a lot of effort from engineering, because probably due to the lack of communication all that months, and without any knowledge what have been done from data science part, that creates a lot of chaos. So and probably I was deviated a bit of your question, but an idea is that a mature and good a team which strives to success in terms of the deployment of the data science project should work not in the same room. I mean, virtually, right? They should be in the same team. They should have one, ideally, product owner, product manager, Scrum Master, you name it. But basically, they should have the same information channels, right, to work, and the same information landscape. That will decrease the communication gap, which will inevitably, increase due to the fact that they work in silo. But basically, in terms of team composition, it's data scientists who mostly work with the hypothesis testing, with the data exploration and data validation and so on. And sometimes you can hear, machine learning engineers. Those folks are most focused on the model development side rather than, data exploration, data explainability side. But sometimes, those two are one single person. So that depends very heavily on the project.
And returning to
Hopefully
this,
I answered the question.
yeah, thank you. To this only less than about this failing data science projects. I mean, only small % of projects succeed, right? And does it make sense then to spend money to this great infrastructure if a possibility of failure is big? What is your opinion?
Another good question. There is no simple answer to that. It's the same as venture capitalists. They invest $1 million to 10 startups, and statistics there is 80% of startups will die, and then only 20% will live. So basically, but those 20% will give such high ROIs, meaning that those $800 which were lost will be insignificant due to the fact that the ROIs will be high. So here applies probably not the same statistics, but an idea is that, so 10 years ago, data science was very much about R&D, right? There were no such mature tools and so on. Right now, due to astonishing amount of startups who are doing MLOps part, data exploration part, data labeling part, and so on, the chances could be low if you do the first steps correctly. That doesn't that includes infrastructure, but as I said, the good idea is to make it simple, as much simple as possible in the beginning. And if you see the ROIs that your model has performing well, it took you not 6 months to develop, but say 1 month, you haven't invested a lot of effort into data labeling, for example, if you require it, and you, speaking of which, if you have data in place, right, for the first thing first, then you can build on top of that, because good infrastructure could save you money, of course. Lack of infrastructure will increase the chances of failure, but somewhere in the beginning of the project, you can at least highlight how your infrastructure should be built so that it could support the project on scale, for example. But as I said before, I would encourage you to start small, to try really simple models. That will decrease the whole risk. However, I should also mention that data science projects are risky by itself, Because before you start the project, before you start the model training, before the model has been put to production, there is no ROI to this model, right? You cannot predict with a like 99.999 whatever nines you want to add accuracy that your model will be perfect on the production data. You never know. That's why data science still could be think as a part of R&D. Yeah, hopefully that also answers the question.
Yeah, okay. And let's say we've decided to use data science, and you mentioned this problem, lack of data. So how much data is needed, actually, historical data? Could you please, for example,
Very
give
good
example, yeah, for weather forecasting or some other project? So when do I start?
Got
When
it.
it
Very,
makes
very
sense?
knowledgeable audience. A very knowledgeable audience. So, if you ask any data scientist, he will say or she will say to you that there is no such a thing like lack of data. Give me all the data you have, right? So, okay, there is a potential answer from the statistics, and statistics tell you that sometimes to make somewhat like not strong, but somewhat okayish thinking about certain event, you can use approximately 30 data samples. Again, guys, do not I know internet remembers everything, but do not put it like that you need just 30 samples to go on. That's not correct. But from statistics standpoint, for some kind of hypothesis testing, that could be enough. Although for data science, I do not think this number will hold. And neither I can tell you how much data you need to solve a particular task, because sometimes for specific models, you don't need much. And then I say much, you don't need hundreds of thousands of examples. You probably need only thousands. But here's the difference. Sometimes you have a lot of classes to distinguish on. Because, for example, class, class of something that means that red, blue, green, whatever, right? If you want to distinguish, number of classes in rainbow, you only have like 6 or 7. I don't remember, unfortunately, right? So that means you will have 7 classes, and those 7 classes should be equally balanced so that your model will understand where is yellow, where is blue, where is other color of rainbow, right? Here is the same. So if your task demands you to have multiple classes, you have to balance, you have to have enough amount of each class so that model will not be biased towards another classes. Also, actually, you can do the following. You can try some AutoML models. For example, Google had one, and Google, guys, I do not remember exactly, but for specific AutoML task provided by Google AutoML engine, it was required probably about 100, only 300 of specific classes to learn on computer vision task to distinguish, lung cancer versus not lung cancer, something like that. So for AutoML of Google, that will be enough. But again, do not hold me to that number. That will really depend on the task, on the model, on the data itself. So there are a lot of variables to that into consideration.
Thank you for your answer. Another question from YouTube chat. Melton Smith is wondering, what is the main tool for data science? How do you process data?
Data scientist. Reserving some work for the folks, right? Well, sometimes you can use ChatGPT. Okay, I'm just joking. So what is the main tool? Okay, as I said, firstly, you start with a business hypothesis, right? However, that holds mostly for the product managers, right? Speaking about data scientists, this is the data itself. You as a professional, aspiring, seasoned data scientist should understand the data to the level enough for you to understand, can you even so can you trust it? It's a very debatable question, but you should understand how can you work with the given data so that it will be consumed by the model and used with a relative, meaningful prediction. What does it mean? It means that, first of all, you need to understand the data landscape. You need to understand if there is class balance, I provided an example, or class imbalance. Imbalance, for the example of rainbow I told you earlier about, is that you will have 90% of data in your data set only for one color, and 10% for the other colors. That will give your model loose thinking that it will, think that rainbow consists only of one color because you provided data to the model only for one color, meaning this 90%, right? The 10% was for another colors. That's kind of a really easy example of class imbalance, which makes very very bad in terms of predictions to the model. So I would put, and yeah, you asked me about the tool. So well, I wouldn't name you a specific tool, but I would name you an approach. This is data exploration analysis. You could do this approach using any tool you want. You can do it through Python, any library. For example, Lux is one of the interesting library I used for the data exploration analysis. Or you can use, for example, R, programming language, also, which has lots of libraries to do kind of interesting visualization and exploration. But data is first, because if you will spend like, I don't know, 80% or 70% working with the data, that will give you a lot of benefit towards the road while you will be training the model, selecting the model architecture, and so on. I cannot stress that enough. That's something which is a lot of folks they skip this phase. They do not put enough attention to the data, and then they're wondering whether a model looks very, very bad, or give really wrong prediction. So that's probably one of the most tedious and probably uninteresting task for data scientists, but it has to be done. And right now there are tools which makes life of a data scientist much easier while working with the data itself. Yeah, hopefully I answer your question.
Thank you. There are still a lot of questions, and
Wow.
you can feel pain in these questions. How
I
to
see.
engage? Yeah, how to engage business people in project continuation process when all parts are done, but it will need improvements in the future.
Yeah, that's actually a part of Go Live challenge, right? But potentially. So here's the thing. That depends on the project itself, on the task which has been solved by data science, and the product hypothesis which has been solved by data science itself. I think that if product management team was working well enough, they should have some backlog of product hypotheses which could be utilized by data science team to work on, to make research on, and so on. That's one point to that question. Another point is actually, which I probably avoided, right now I think about it in my presentation a bit. This is monitoring. Model monitoring in the wilds, then the model is in production, is a part of MLOps practice, MLOps approach. But that's another point where you can stress it to the managers, to the any stakeholder. If that haven't been done enough, or if you build a model and you have some monitoring but not good enough or something like that, that's another way or another layer how you can enhance your project, because model monitoring is crucial in terms of, since data itself is not something set in stone, it changes frequently, depending on the task, depending on the domain, of course, but still it changes. And your model have to be retrained on the new chunks of data constantly. And this is first thing. And second thing is that most of the time, ML models in production fail silently. You never know that it failed unless you have received a lot of angry customer reviews, or guys from engineering suddenly realize that your model returned from prediction of price of something, it returned 0 or something like that. So that's another angle which could be looked upon. And the last one to that question would be, throughout exploratory data analysis, sometimes you can uncover some really interesting some interesting product insights, based on which you can even create a new hypothesis. But in order to do that, you have to have subject matter experts in place, or at least someone with whom you can consult about it. And in order to avoid challenge I told you about, if you just start a project with the data without even understanding what this data does mean, that's the reason why subject matter experts are really helpful here. And I know a couple of projects where data scientists were, intertwined together with the subject matter experts, and that lead to really promising results in terms of data science project outcomes. So yeah, that's another one.
Yeah, I think there are enough reasons to go on with the data science project. And another question is there a right approach to give data science access to personally identifiable information data and not to violate GDPR? Is there a right approach to it?
Actually, we at EPAM, on the right of marketing, right, do have projects which will do this kind of stuff. They will de-anonymize your data. Not only EPAM does have this product, but also other companies as well. So basically, yes, there are there are numerous techniques. How can you anonymize your data before a data scientist will touch it? Basically, if you speak about US, you cannot touch PII without, I don't know, thousands of NDAs and so on. It's very tricky topic. And yes, PII should be anonymized before it reach any model, before it reach any exploratory data analysis. Even more to that, there is a part of responsible AI here, which not only take into account PII data as a personal identifiable data, right, which is very confidential by its nature, but also how the model will treat those minorities, right, in order not to use any features, but it's only part of responsible, right? There are different angles to that, but basically, in order not to use any features which could discriminate people, such as age, such as gender, such as skin color, such as nationality, and so on. That's another very, important topic which somewhat connects to the PII, but not directly, right? But still, it's also important point to take into consideration while model training and while data exploration as well.
Thank you. One more question is, can you elaborate on the role of the data science product owner? How does it differ from a typical product owner?
Well, another good question. That really depends on the project itself, because sometimes, data science product owner could be think as a technical, like product manager, technical product owner who is who is enough versed in the data science concept in order to distinguish, supervised models versus unsupervised models. When do you need to use deep learning? When do you not need to use deep learning? Spoiler amount of data, right? And that's it. This is my personal view on this topic, because a role of data science product owner or machine learning product owner is very new to the market even now. There is no kind of proven job description to that. But my personal opinion is that product owner should be, again, well versed in the data science concept enough to be talking to the data scientist on the same language, to understand why data scientists use this metric, and what does this metric mean. I mean, loosely speaking, right? You do not need to calculate that metric. If you want to go one step ahead, you can train yourself enough to be able to create proof of concept of some ideas, again, using Python or R, well, probably Python, right? And to check if the given hypothesis even works out using data science or not. But that's something which is not very, often you can find on the market. Basically, I would opt for understanding the science concepts firstly. Secondly, understanding metrics, which were used for the specific algorithms, right, and for specific models. And most importantly, as I said in the beginning, how will you translate the model metrics to the business metrics? And that alone could give you a lot of advantage. If you can do that, you can, you don't need to know how to do Python code and so on. That will alone give you a lot of advantage. That's my point of view.
Thank you, Nikolai. We have some, funny question at the end. So, what is harder, rocket science or data science? For the
Elon Musk
finishing
entered,
of our
Elon Musk entered the chat, right? Well, rocket science, of course. It's no way to think about it. At least in rocket science, you can. Well, actually, not. You cannot promise anything. So yeah, good question. Good question. I would opt, even though I am data science fan and so on and so forth, I would opt for rocket science. Because rocket science, come on, you're building ships to go to the Mars or whatever. So yeah, data science is a tool. Actually, one more important part about thinking. Well, to my mind, correct thinking. Data science is just a tool which supports product. In my way of thinking, in my universe, there is no data science without a product. Unless you're speaking about Google, Meta, any other huge corporation which could pour millions into R&D, right? But basically, I think about data science as a tool which supports the product, which helps product to reach more audience, to reach some meaningful business results. That's why I named the presentation "Business Challenges." But it's my way of thinking. It's not necessarily correct, but it's much easier for me as a product to think about it in this direction.
Well, thank you very much for your presentation and for your answers. That was a very interesting talk. We are glad to have you.
It was interesting questions. Yeah, that were very interesting questions. I really even sweat a bit on some of them. So yeah, that's cool. Thank you so much.
Thank you everyone for watching. And our next speakers will be in 6 minutes. Hello everyone. It is Winter Data Meetup from Zen Community. Our speakers are Volha Pivavarchyk and Alina Martsinovich, and they will tell their story of using Power BI to improve data management processes without writing any piece of code. Please don't forget to ask your questions in the YouTube chat. Hi Volha, hi Alina. Nice to see you here. The floor is yours.
Hi, everyone. Again, thank you for joining the conference and our presentation in particular. Let us again start with some introduction of ourselves and the plan of our speech. My name is Alina Martsinovich, and this is my wonderful colleague Volha Pivavarchyk. We are pre-sales analysts, and we are primarily involved into research activities. We've divided our presentation into three main parts. And in the first part, we'll tell you some general information about our team, who are our typical requesters, show you some examples of the research we conduct, and provide you with some basics on what we are doing. The second part will be devoted to the problem we faced. And finally, in the third part, we'll tell you about our solution. So let's get started. Let's start with the first part of our presentation. So who are our requesters? We usually serve account managers, sales managers, marketing professionals, and consulting representatives. Speaking about key locations, we'd highlight North America, EMEA, and APAC, but we've already conducted research on almost each spot of the world. And to clarify the typical use cases for reaching out to us, let's move to the next slide. So there are 6 typical use cases for reaching out to us, but an important remark, we usually serve our requesters across EPAM internally. And the first use case is proposal preparation. For those who is not familiar with this term, a proposal is a piece of document that outlines everything we propose to do for the client. That's why it's important to have a clear overview on what is going on in the client's business, what is the key weaknesses, what is the key strengths in the company. And that is what we usually help with. The second use case is an account plan creation, what is an essential process of client acquiring. The next important use case is market trends impact verification. Here we find the information on what is going on in the market in general and what is the key trends in the market. We also help in getting ready for a meeting with the exploration of competitor expertise and becoming up to date on account news. So there are typically 3 types of reports we create: account report, contact report, and market report. And on the slide, you can see the first type of report. This is an account research and account report. And it usually includes some general information about the company, key initiatives, recent news, and many other valuable information. In contact report, we usually gather information on a person or a group of people. And we usually add information about company name, title, key responsibilities, educational background, and even interests and hobbies. In the market research, we usually overview current market state, key trends, key figures, who are the key players in the market, and other significant information, significant facts. So, Volha, I give you my word.
Thank you, Alina. So I would like to talk about the problems we faced during our work and the solution we found. So we are constantly working with a huge amount of data, and currently we store about 17,000 different documents. In addition, we receive over 100 new requests every month. And this means that the number of documents stored is constantly growing. And our stakeholders need to wait for a while before we can start working on their request. Let's move to the next slide. And the main problem for us was that our reports were uploaded to the archive and became outdated. We shared them with our requesters, but the information itself was not aggregated and was not used for more complex analytics, like analysis of industry and technology trends. We also saw our stakeholders' interest in a system that would quickly provide them with concise information about what is happening in a particular industry, such as information about industry trends, major industry players, and so on. Let's go to the next slide. And that's why we decided to create a market trends analytics solution, which must have interactive and reusable content, consist of easy to understand tables and charts, and which will simplify our work and save our time. And Power BI helped us realize our idea.
For those who is not familiar with this tool, let me tell you a bit about this tool. It's an interactive data visualization software product developed by Microsoft company, and its primary focus is on business intelligence. It's part of the Microsoft Powerful Platform, and it is some kind of a collection of software services, applications, connectors that work together to turn unrelated sources of data into coherent, visually immersive, and interactive insights. So there are multiple reasons why we choose Power BI. Since we're not technically savvy, it was important for us to develop a tool that would be easy to use. And in addition, there are multiple tutorials and educational materials available in public sources. We are advanced users of Microsoft Excel, and it's really convenient for us that the tool is well integrated with Excel. There are a lot of data visualization options, so you can interact with each chart of the dashboard easily. And there is also an automated updates feature. So there is no need to make any updates manually. We can say it's rather user-friendly. We have never experienced any challenges with the interaction with this tool. And we even had an ability to try the product before we bought a license, and to understand whether it works well for us, whether it meets our needs. And the license price is relatively low in comparison with other business intelligence tools available in the market.
On the slide, you can see one screenshot of how our trends analytics solutions look like. It provides us with the insights on industry and sub-industry trends, major market players, their strategic focus and actions, and technology tools they use. At the moment, it is MVP, and we are actively working on it. So let's go to the slide with benefits we received from Power BI. Firstly, it reduced time needed to create our market research reports. Previously, we needed to search for some industry information manually, and the more categories of the market we needed to explore, the more time it took. Now, when we create account research report, we just transfer key insights from it to Excel spreadsheet, which is already integrated with Power BI. And the analysis of our account reports provides us with the necessary information needed for market research, as we receive the insights from about industry trends directly from them. This helps to reduce the time spent on market analysis by at least 1 day. Secondly, we don't need to worry about the relevance of information because all of our updates in Excel are automatically uploaded into our Power BI model. Now our stakeholders do not have to wait for some time while we can start working on market research for them and share the results. They can use the link we provide to enter Power BI, select a specific industry, and view the information they need. This helps to save both our and their time. In addition, the information that is displayed in the report is quite concise and easy to understand. Due to the fact that we don't need to read once again large pieces of information. Large volumes of text and other data have already been analyzed by us, and they are presented in the forms of tables and infographics. And of course, we don't have to go through all of our old reports to find the information we are interested in, since we have the ability to find key industry information in our Power BI report. Let's go to the next slide. So despite the value we have already received, we are constantly developing our model in order to get more accurate and more detailed insights. So we are going to add more categories on the company, like information about the company's revenue, location, and size. Of course, we want to add more details on companies' action status and the result of their actions. We will add this information if it will be available in open sources. Let's go to the next slide. So if you want to learn Power BI, there are many useful resources for this. During our work, we used EPAM on live sales study courses on Power BI, but they are available only for EPAM employees. Speaking of open sources, one of the great sources of information is Power BI tutorials from Microsoft. It provides step-by-step guidance on how to use this tool, starting with how to install Power BI, to how to share and update reports and dashboards you create. It also includes detailed how-to guides on how to work with tables, visualizations, formulas, and so on. On the right side of the slide, you can see some screenshots of the materials provided by Microsoft. In addition, a large number of materials are available on LinkedIn Learning and on YouTube. They are easy enough to find just by entering the name of the tool on the search bar of these platforms. So this was our presentation, and thank you very much for your attention. And if you have any questions, they are welcomed.
Thank you, everyone.
Thank you for your presentation. Yes, there are some questions. So do you know what kind of data source do you use? Is it some SQL database? What do you mean when you say documents?
Yeah, we usually create our reports in PowerPoint format and Excel documents. That is the two main types of documents we use.
But when you, what do you choose for the source? When you create report in Power BI, what is your source data? I mean, some Excels or is it some database or some Excel files?
We find the information from open sources, from public sources. So it might be various types of the documents.
And we integrate our Power BI reports with Excel spreadsheet.
With Excel. Okay, and you already mentioned how did you learn Power BI and provided very nice resources. Thank you very much for those links. And the question is, does it really, is it really no code? So do you have to know some coding, or have you used
No.
SQL, for example? No,
No,
is it just...
unfortunately, we don't know any code because we are not, as Alina said, technically savvy. And that's why it was sometimes challenging for us to understand some features, but because of the availability of a great number of tutorials, it was relatively easy to understand the tool.
So you actually encourage our listeners and watchers, just, even if you don't know how to code, you can use this tool.
Yeah.
To get some insights. And
yes,
you
it
told us...
would be Sorry, it would be some slogan. Do not be afraid to use business intelligence tools or work with data if you're even not technical savvy.
Yeah, but you need to know Excel, right?
Yeah.
Without Excel, there is no way. And you told us that you need to export and share reports. And is it possible to save them directly in Power BI as files or like PDF?
Yes, it is possible to save them in PDF files. But if you want to interact with some tables and charts, it is impossible to use PDF files for this. It is better to use web versions of Power BI.
And also you mentioned about Power BI license. So what is the difference between free and paid version?
The difference in sharing the files, you can use we used a free desktop version. It is free for all users, but you can't share these reports with other people. You can only share the document you create and send it to people who have a desktop version of Power BI. And when you have a license, it gives you the ability to create a space with other people, and you can send, just create a link for your report and share it with other people who don't have a license.
Okay, thank you. Looks like we don't have any more questions, but thank you very much for your useful presentation. It was very nice to have you here. And our next speaker will be in. Okay, we have another question. Can you demo your solution in Power BI?
Unfortunately, no, because we have sensitive data there and we can't share it with other people.
Okay, so
Yeah, for
continue.
now.
That's too bad. But it's good that we are, hiding the confidential information. So to continue with the Power BI topic, our next speaker will be Aleksei Marchenko, and he will tell about data lineage with Power BI, and it will be in 30 minutes. So thank everyone for attention. Thank you.
Thank you.
Thank you.
Bye.
Welcome back, and this is Winter Data Meetup. And our next speaker is Aleksei Marchenko, who will share his interesting talk about creating a visualization of interactive visual representation of data flow using Power BI. So, Alexei, floor is yours.
Okay, thank you. I would also mention that that visualization, that tool is, let's say, at no cost, because Power BI is allows you to use your Power BI desktop application, create and publish it to the web and share the link. Well, considering that it is not secure, but if not sharing to the web, then just access through your password. Nevertheless, let's start. So what I'm going to tell you, well, some words about myself, of course, what I'm doing, maybe something about the context, what is the data lineage and why we are using it in our daily work as a BI analysts, and how it is done through source to target mapping and through further visualization. And if we will have time, I will also show what is under, how queries within Power BI are done, and how it is all implemented. So let's start. Well, I have a variety of experience. Actually, I have worked not only in IT, not only fulfilling those roles mentioned here on the slide, but also working as a lawyer and some other roles actually. Anyway, if we're talking about IT, I was here not only BI analyst, but also a project manager, and was in charge of the whole data in one comparatively small organization, of course, comparatively to EPAM. So what do I do now as a BI analyst? Well, actually, it's a sort of superhero because we deal with all these aspects within the project. Not only working as a BI analyst, understanding what is required, what needs to be done, or what are the business processes, and so on, but also about how it should be. Well, that's all about data projects. So we are investigating what are the data that should be consumed, how it is to be transformed, and of course how it should be reported in certain tools and visuals. And doing that, there is no way not being a data analyst, not querying data, not understanding it, not profiling, and all that stuff. And of course, a sort of architecture guy who needs to understand and even a bit design what is going to be done, how all that data project should be implemented. And when proceeding to the implementation, there is also a role where a BI analyst even work as an engineer, and especially for the side of reports and visualizations. And when there is no specific engineer on the project, he plays that role on a project. That is usually a Tableau developer or Power BI developer. And then, or even before, doing all that testing, organizing tests and quality assurance. That's it. And given that, we are usually dealing with the project, and that is a conceptual sample, what is inside of each data project. As you can see, there are a lot of transformations, consuming data from various sources, transforming it, and then building all that stuff over that transformations. Here I marked that in red, those boxes that are about that data lineage that will give a light on what is that in the whole concept of a data product. Let's go. Here it is. So in every project, everywhere, we need to understand what is coming in. And here we've got in any kind of tool to be in place data source registry that is coming out of certain data acquisition layer. And so we need to understand it and somehow document it to be available not only to the developer's mind, but also to analysts, to anybody who would like to go and look behind the hood in the project. Then, of course, getting data, we need to understand what's happening inside, how it is transformed, all that detailed stuff. And of course, what do we finally get? And here there are some additional terms that are, of course, connected to data lineage. That is metadata, that is everything about data, data about data. That is understanding what assets, what units, what key data elements we have. Having for all that sort of data glossary that will translate us the meaning of, let's say, attributes of any table to its actual business meaning and be a bridge between developers and business. And finally, data lineage. That can be a term that describes what's going on during all that data transformation. Here is a good picture telling us what is that and actually why it is done. So here we've got a sample of sources, transformations, layers in between source and target, and everywhere, beginning from any box here, we need to understand what data we have consumed, is it required elsewhere, what's happening actually. And we should be able to do that forward. It means from the sources of each layer, how it is connected to the next step, next layer, and also backwards. Like I see certain KPI in report, what that mean, where it comes from, and step by step go into the source. What sources are required to build that KPI and how it is actually done. So in any organization, in that or another way, data lineage should be in place. Why? That's because, well, it shouldn't be in the head of a BI analyst or a developer, and should be present to be able to be shown to anyone, so that next developers or business or whoever wants will be able to deep dive, to investigate, to understand where the data comes from, and when switching to another sources, doing certain migrations, anything won't break, because you've got picture, you've got understanding what's going on, what are the links between certain layers from source to target, and well, that saves a lot of time and money accordingly. Given that, there are certain enterprise tools for a data lineage. Well, you see the leaders here. Calibri is mentioned. That's actually a tool that's on the current project that I'm looking at, and the Power BI report that I have built and sharing now, it was actually built for production for our certain use for the use of developers, for our team and for our stakeholders both. And here I would like to mention that nevertheless we have Calibri at place. and that is a very powerful tool that can do many things. But nevertheless, we have done a Power BI report. Why? Well, not mentioned here, because in our case, it is slow, unfortunately. Too many assets, too many relationships, and we needed a quick solution that will allow us to give a quick picture, to capture a brief understanding on what is going on, and proceed with our pipelines enrichment. And besides that, Calibra costs money. I actually don't know how much, but it costs. And of course, there are in-company regulations of how it can be used, who has access, while Power BI and certain, let's say, on-hand tools can be a good reason for MVP, for data lineage MVP, building that quickly and without breaking corporate tools and corporate policies for that tools. So let's go from words to the picture. That's actually what we did. We came to a project, and on that project there was that kind of transformations. Here is a table level transformations, describing what goes where, which tables are used, and let me show the same in the report that we have developed. Having the picture is fine, but we need to get more interactivity. Here we've got sources, then transformed through certain layers to the final reporting views, not even reports. How we're using it. So let's say, for example, we need to understand that table, what is used there, where it goes to, and besides that visualizations, we've got here a table with certain links to a Confluence page where all the transformations can be detailed either, well, in any kind of, there can be a part of a code, there can be a visual that describes the logic inside, and so on. Same with the nodes here, so we can click at any node and understand, okay, in order to build that so-called auto book table, we need certain sources. There are certain scripts doing that. They all are in certain DAG, and here we are getting quick descriptions what's happening. If one wants to go to more detailed descriptions, here's a link. Click, drill down, and investigate further. That was our first step. Let me give here well, that looks like a source to target mapping, and it is it actually. In the classic source to target mapping is well, actually a table that describes the source, transformation rules, and what is the target for certain transformation rules. There can be any other details, whatever you want. That's well, upon the decision of team or whoever is doing it. So in order to deep dive from the table level to the level of columns of how they are transformed, we have started to capture this in a certain Excel. Here, as an Excel file that is used further on to be visualized through Power BI. That's actually a table level. And the logic here is pretty simple. So we need to describe, to show what is the source. All we want to show here about the source, we capture here. Well, database, schema, table, whatever. Then for each source, we have certain targets. Or let's put it in another way. Let's start from targets. That will be better. For each target, we've got anyway in all those transformations, we are getting targets. And the question is where it comes from. We have described targets, and in order to describe where it comes from, we tell, okay, there are certain scripts, certain dogs, and here we can place a description, a quick description of what's happening on if it is not enough, or there is an option to deep dive. Here can be a link either to Confluence with the text description, with any kind of description, or even write to the code, like here. Okay, we can drill down into the code, or into the description of the code, and out of there to the code, and that will describe us, bring us to what source is used for that. On the table level, that is pretty simple. That is actually used for visualization that I have already shown. Drilling down into the columns detailization, we've got certain transformation on the column level. That means we now need to do the same for the column. So that means for each column that we have described in that part, we've got certain source and a description how source has been transformed to the target. So here all pretty much the same logic. What DAG was used, what script, URL to the script, or URL to certain description of this script on Confluence page, and a short description. When we have this, we are able to dig down further on with the use of visualization. Okay, Excel is pretty enough. You can look down here, you can find certain fields and try to understand where they come from. But that is not enough. We need to do that source and target mappings that can be visualized. So let's see how that is done. There are several ways to do it. Let me show the first one. Several ways to do it. We can use any one that will bring to the same result. The result is to understand what is going on. Let's just try a backward analysis. Let's have an example of I have seen in some of reports certain field. I need to understand where it comes from. Let's take a region cluster, for example. Okay, here I get that on the tables level, it is coming from here to there, and we can see that both in visuals or in table form. So we can see that, okay, region cluster is coming somewhere from another level, and the source columns for that are cluster and cluster shift TCD. To dig down further, we would like to understand, okay, and what is the source for cluster and ship to CD? So we can add this. We can add here, okay, and now add here a cluster, understanding where it comes from, and add here ship to CD. And here we are getting the full path from the first level to the latest on how it is transformed, table level, column level, and all the same with certain descriptions, links, all through the source to target pipeline. So we can click here, read about it, or understand out of this small piece of code how it is done. Of course, everything is clickable here. That means that, okay, I need to understand that part. I click here and see what is happening here. Or I need to understand both what is coming in to that node, what is coming out. I click to the node and see certain detailed description in a table. That is one way of visualization. And another one, well, that's how to choose between them. Whatever you like. Whatever you like, you can go to another way of looking inside. Let's try to use that same column. I want to understand where region cluster comes from. Okay, I search for it and see, okay, it's coming to the latest level from these two views. And those views, we need those columns. And can dig further and further on, understand what is in turn source for that cluster and that ship to CD. Let's quickly show that it is possible also here. Okay, we've got further drill down to what's coming into the final region cluster. And finally, another way of visualization. Well, that actually requires a connection between all these tables that are in the transformation pipeline. And instead of getting visualization, we just know that, okay, region cluster, that is for developers or analysts who understand where is the region cluster, on what level it is. Well, in that example, I do know that it is a final report that is presented on a dashboard, and for each level I can see the sources that is finally resulted in a region cluster. And of course I can click on any of these in turn steps and understand what is used to build certain target. Well, that was their backward analysis. So same can be done for the forward. What it means, now we're trying to look from target to the source, understanding where the target comes from. Same can be done from the source to target. So here there are all names from all name fields from all tables. Let me put here an example for, let's say, product CD. And sorry. I was choosing product CD. Well, I've got the source. I see that it is coming from that column of that precise table, and so on. I can dig further on and understand the target column. I've got the target column product code. That target column is in turn the source for other columns. That gives me ability to proceed searching for the product code. And adding that, I will also get what is the source, where the source product code is used further on in all the pipelines. And here it is. I can go further and also keep clicking and understanding how that product code goes through all the pipelines up into the report. Well, that's it about what we've got as a result. And here I can go to the, well, can show what is done inside Power BI, what queries are built in order to make that possible. Before that, let me look through your questions. So, well, it's a production report, but actually you won't see here any production data. So that data was anonymized before the presentation, of course. Caption should is considered. Well, the question about what should data lineage should capture? Well, it should answer the questions for you. What's happening with my data, where it's used and where it is not used, and what is the source and where the target is coming from. The question was about if there is an attribute in a data set that is changing, but is not taking part in a transformation, as I have understood the question. If it is happening in terms of data lineage, in terms of answering to the questions we have, there is no need to capture that. If value of an attribute changes, okay, that's a normal behavior for the values. If let's name an example, let's take an example when the name of an attribute changes, of course, that needs to be captured in data lineage. We should change it. How to change it? Oh, okay, now we've got that source targets, and now let's assume that attribute is a column. Name of a column has changed. We change it here. That's it. Another question. Looks like you can solve any task with Power BI. Do you use it for any kind of personal purposes? Yes, of course. That's about the latest example is taking the data from my brokerage accounts, from investments accounts, combining them and showing the results of investments all in one through all the accounts in one place. That is a sort of how visualizations can be used and analytics can be used. In terms of ETL transformations that are inside Power BI can be used for transformation also. Also, I was parsing the advertisement at the sites, my home GA, SSGA, that are for the flat rent and or the flat for the flat selling, and taking all of those advertisements that I haven't yet seen. because they are renewing, and there are a lot of advertisements that do repeat when you try to search them directly through the sites. Well, combining two sites together and filtering out what is not yet seen. That is ETL application of Power BI in my private life. Next question: was Calibra slow to develop, implement, or slow to run? Well, actually both. Well, Calibra is a tool, well, not developed by us. It is a corporate level tool. In order to implement this, there are certain well, trainings to be passed, accesses required to be got, and well, it's a long run. It's a long run, and when using it, it's not that quick as I have shown you, and well, it is much more powerful than Power BI, but not so quick either to implement or to develop. Well, that's it about the questions in the chat. So I see that we do have some time left, so that I can show a bit inside Power BI how it is technically was done. Let me open certain file. Well, here is a query open. Let me close it. And Power BI, here it is. So desktop, Power BI desktop. Of course, first what we need to do is make certain transformations. What are they? There are two kinds of. Let me try to quickly show how that Sankey diagram was built. In order to do so, for each table that we have in source target, here are the tables for certain targets. We are describing what are the sources, and that is done for each table on each level. So we are getting those tables. Here are some queries getting those tables with minimum transformations, just collecting them all together, and finally we collect that into so-called Sankey columns. That is also pretty simple. It's just combine all tables in one. And finally, we are getting that kind of table. Let me show it perhaps on the free page in that report. So all tables combined in one gives us that table Sankey columns. It looks like that one. All sources, all transformations, and all targets put together. Big table. And if we will start putting it here on visualization, well, it will be the same table. But what can be done within Power BI, it is that Sankey diagram. Let me perhaps show a quick transformation of it into the table and back. Let's start from the simpler one. So we've got table. We've got table, Sankey columns, all coming from Sankey columns. And what we are placing on the visualization, what we need to know about transformations. Let it load. Transform it back into the table, I guess. Here it is. So actually, that's simple. We've got source table and target table. Fortunately, we've got those names unique. There is no duplicates in naming. Otherwise, there should be a key. Those sources and targets should be unique. Since you've got it, since those source and target are unique, and all you need to do is just drag certain columns to visualization, and just click to visualize all that table into Sankey diagram. And here it is transformed into a diagram, and that's it. Well, we have tried to build the same in Tableau, but it wasn't that quick, not that easy. Why Tableau? Because it's also a reporting tool used on a project within a company of our client. Well, now, not that easy to do almost the same in Tableau. And I actually shared that presentation that I'm doing now on a Tbilisi Data Fest, and then found some guys who even doing all that stuff not for themselves, but for a client. So here we've got actually technical data lineage that gives us how technically data is transformed through the pipeline. They have gone further on, and they have implemented even data dictionary through that kind of visualizations or a similar kind of visualizations, so that you can go through the business meaning from the definition written in certain business language into the technical lineage, to the sources from the zero level. What is needed to build certain KPI with a certain business definition. And since guys are building pretty much the same in prod, well, I think it would be available to share with you, or also the reason I'm sharing it, it's a sort of chance to get feedback, like there is another way, there is a better way, there can be other visualizations used, or Tableau also can be used for it, because it is also easy to use it in Tableau. Maybe I'm not that good Tableau developer as Power BI developer. I know both. A little bit better in Power BI and less in Tableau. So here.
Thank you, Alexei, for your presentation. We have one more question. Yeah, how do you merge data without common key and many-to-many relationship? Yeah, I don't know how
merge data without common key.
Yeah, you can read the question.
Yeah, yes, I do understand. I can read the question, but actually, common key. Well, I don't understand what common key means here. As a key, we use. Well, I said that our names, that column names, are well, not common. It's the table names. They are unique, and that gives us a reason to use them as a key. Well, that's it. The name is a key, and that allows us to merge this into the Sankey diagram through the visualization. And if you are talking about the connection between data layers, of course, the last visualization that I have shown, it requires many relationships, because all same source can be used in many targets, and certainly many targets can be coming out of several sources. What is good with Power BI, and why it is not implemented in Excel, because Power BI has that many-to-many relationships, and they can be activated even they are not active now. So here we've got a connection by source to Well, that's a zero level. Okay, naming convention. Anyway, many-to-many relationships, they can be processed by Power BI, and that's what Power BI is doing.
Okay, yeah. Thank you very much, Alexei, for your presentation. Yeah, so if anybody has any more questions, I think they can connect you directly. Yeah, via community platform. Yeah, thank you very much, Alexei. So, yeah, next speaker will be Dmitrii. He will share a great story about using Apache Superset tool. So, yeah, see you in a few minutes. Yeah, thank you.
Thank you.
and this is Winter Data Meetup, and our next speaker is Dmitrii Nagaev, who will tell everything about such tool as Apache Superset. So if you haven't heard about it, this talk is for you. Dmitrii, floor is yours.
Good evening. Can you hear me well?
Yes, yeah, great.
Excellent. Let's start. Today we will talk about Apache Superset. This is a business intelligence application. We will take first steps that you need to get your first dashboard. There are connection to database, creation dataset, creation charts, add charts to a dashboard, and more and other things. Before I start my story, let me introduce myself. My name is Dmitrii Nagaev. I have been working at EPAM for the second year. I worked with 1S Enterprise before. This is a Russian ERP system for accounting. Then I worked at the university as a senior teacher, and at the same time I worked as a freelancer. I was a full stack developer. I had been creating websites on PHP, MySQL, JavaScript for more than 10 years. At the same point, I wanted to change my vector. Vector of my development. I went to a 6-month course at EPAM. It was business intelligence direction. I finished it, settled on a project. Another BI tool that has name TIBCO Spotfire was used on this project. The ambassadors had the task. They wanted to get custom visualization on BI tool. They also wanted to change expensive TIBCO Spotfire with an open source product. This product was Apache Superset. I began to study the Apache Superset for this reason. I received a task to implement custom chart on the Go.js framework into Apache Superset. At the same time, another developer had a similar task for TIBCO Spotfire. On the left side, you can see a chart for implementation into Apache Superset. On the right side, I found an existing tree map chart in Superset. As you can see, they are different. Tree map chart also has a limit, just 3 subchilds, first subchild, second, and third. And I cannot change color for this tree map chart. Therefore, I needed to create a custom chart. My learning of the Superset was untypical. At first, I learned hard things and then simple things. You can see the technology stack used in the Superset. At that moment, I had known just Python as a junior and JavaScript. I didn't know React, TypeScript, Babel, NPM, and so on. I asked the delivery manager in one of the meetings, why do you choose the Apache Superset? What did you like about it? He sent me a link and said, please look, there are many well-known companies use Apache Superset. Do you think they are wrong? And then he continued, in addition, Apache Superset is a modern data exploration and visualization platform. Superset is fast, lightweight, intuitive. It's created for users to explore and visualize their data. They can start from simple line bar charts to highly detailed geospatial charts. That's why we want to try the Superset. I searched information about the Superset in internet. Superset came out of the Apache incubator. It had renamed 3 times. Names are Panoramics, Caravelle, Superset. The developer of this BI tool is Maxim Bushamin. He worked in Airbnb company at that time. He also created Apache Airflow application. Maybe you know this application, which also had on which we also had this application on a project. I learned that there are 3 different ways how to install the Superset. There are locally via Docker, installing from scratch, and using Superset in the cloud. To develop the plugin, I needed to install Superset from sources, because file modification and creation required. If you want to start working with Superset, I recommended Docker installation or Superset in the cloud. Superset in the cloud has a similar interface, but with less differences. No matter which option you will select, the result will be the same. After you install and log in into Superset, you will see a page with a list of dashboards. There are 4 main menu items in the site header. It's data, charts, dashboard, and SQL Lab. This link you will use often. There are also settings menu, language menu, and user menu. First of all, you need to connect to database if you want to build any visualization. I found a list of supported databases in the documentation. The instruction set Superset uses SQL Alchemy for connection to the database. If SQL Alchemy can connect to database, it means you can use this data for charts. You can also create your own connectors on Python code. My project used an Amazon Redshift database. I was happy because I found it in the list, but I can't connect to Redshift right away. It turned out that the Superset had only SQLite package installed by default. SQLite package changed to Postgres package in the new release. In my case, I needed to install the package for Amazon Redshift database. You can see the code on this slide. This code can be added to the Docker file or can be run via command line inside the Docker container. After that, connection to database became possible. To create a connection, I went to databases, and after that, I just populate with fields: host, port, database name, username, password, and click connect button. Superset has 2 options to connect via user interface. You can see it here on the right side. And the second variant is URL string, favored by DevOps. The string contains the same parameters, but it's just a string. You populate with field, you can click test connection button, and after that, click add button. Next, we need to create a dataset. There are 2 types of dataset in a Superset. It's a physical dataset. Physical dataset is like a regular connection to a table or to a view. When you are creating a physical dataset, you need just populate this field: database, schema, and table name. And after click add button. After that, you will have a physical dataset. The data usually locate in different tables for one chart. You need to create a virtual dataset for this case. You should use a SQL editor in SQL Lab. Just create a SQL query with joins, unions, save with query, and you will get a virtual dataset. You should know that Superset is a thin client. When you are working with big data, it's better to prepare data marts on the database side for better performance. it means the better use a physical data set. The dataset has settings. If you click this button, edit button, you can create metrics for every dataset. You can create calculated columns, and you can set a cache. Okay, now we created a connection to database and dataset. Now we can create a chart. You should know that each chart is a separate SQL query to database. The superset receives data and builds a visualization based on this query. On the left side, you can see available charts in the superset. On the right side, you can see user interface, UI. In this interface, you should select dataset and select any chart you want to use. And after that, just click Create a New Chart button. On this slide, you can see interface for creating a country map chart. The block on the left side, the block on the left side contains the dataset. If you click on a button with three dots, you can change dataset to another dataset. Below are metrics created in dataset settings, and even below columns from this dataset. The block to the right contains chart settings. To build, if you want to build this chart, the country map chart, you need to set up minimum 3 number of fields. It's a country field, ISO field, and metric field. Country field is a field with country names, ISO code, and metric field populated from dataset columns. And after that, you need just click Run Query button, and you will get the result. A similar process for building a bar chart or another charts in the superset. On the left side, you can see the same block with dataset, with metrics, with columns. The block to the right contains parameters for this chart. This chart has just two required fields. It's metrics and series. Metric as a fact parameter and series as a dimension parameter. You can also change another parameters if you want. For example, change sort by parameter, and after that you click Run button and you will get the result. If you like this button, you can save this button, and when you click on the save button, a pop-up window will appear. You need to specify whatever you want to create a new one or overwrite the existing chart. Next, specify the name of the chart and where do you want to place it, to an existing dashboard or a new one. And after that, click Save button. So after we created several charts and placed them on a dashboard, we can get something like this. Here is two different dashboards, first and second dashboard. Each block on a dashboard is a separate chart with a separate SQL query. If you click on a button here with sign like a pencil, you can edit dashboard. Charts are not always arranged as you intended. So for example, you can resize it, drag and drop it. You can also drag and drop additional components. It's tabs, rows, columns, header, markdown. And then you should click Save button. Each dashboard has properties. You can specify the chart name, URL flag, owners who can modify this dashboard, and roles who can read information on a dashboard. The Superset also contains additional settings. Main of them are data access roles. Permission can be set for each role, what this role can do. Next, it's row level security. Display on a dashboard information intended for a specific role. For example, role alpha can get sales in the USA country. Role beta can see information just in Canada, and role gamma can see all information for all countries. The system can also send alerts when the controlled parameter reached the certain value by email. And Superset also has reports sent at the appointed time on a email. When the dashboard is ready, you can transfer information from dev environment to production environment. The Superset gives ability to export dashboard like a zip archive. Archive contains YAML files with dashboard, datasets, charts, and database settings. On production, you can import this zip file to Superset. This process can be automated via Superset API. For example, you can receive zip archive, unzip it, commit to Git, Bitbucket, or etc. Then zip again, import on production by API. Let's return to the story with my custom chart task. After 3 weeks later, I had a working prototype. And after another 3 weeks, I finished my first custom dashboard for Superset. The chart had a lot of settings. On the left side, you can see a simple chart with less data. On the right side, the typical chart with many dependencies. Chart also had filters. It's a separate chart in Superset. By the way, another developer didn't resolve the same task on TIBCO Spotfire. I wondered why he didn't success. During the holidays, I watched videos, read forums, and after 2 weeks, I made the same custom in a Spotfire. But that's another story. Maybe I'll tell it at the next meetup. For me, the main features in Superset are cross-filtering. This feature was added 6 months ago. Now some charts supported. The next feature is an open source with active development. Another feature is a drill down, is usually asked by people. The developers did it something similar in the latest version, but it's working with another. It's not like drill down, but it's similar with drill down. And you can also solve drill down by custom charts. Well, Superset is a good choice for organizations that are looking for an open source, flexible, powerful BI solution with a user-friendly interface and good visualization capabilities, but may not have the more advanced analytic requirements. Superset has a good balance between easy of use, customization, security, collaboration, and scalability. There are helpful links that I shared with you. Thank you for your attention. As you can see, this page is also a chart from Superset. I'm ready to answer your question.
Yeah, thank you, Dmitry. Very interesting topic. Yeah, also we have questions. Yeah, there was a question about websites and blogs to learn Superset. Yeah, could you show them again? And are there only like videos, or also there are courses? No, there were GitHub is material about Superset. Yes, this one. Are there only documentation, also video courses?
There are two YouTube links. It's videos on YouTube, and it's a developers meeting on YouTube.
Okay, thank you. Yeah. Also, I have a question. So, what knowledge is required to start working with Superset? Is only SQL knowledge, or also Python? So, what is your background, maybe?
If you want working as a BI specialist, I think you don't need to know SQL. It will be good if you know SQL queries, but you don't need a SQL query at the first step. And think that's all. And you need install Superset to your machine or into any server. That's all.
Yeah, and also regarding those custom visualization. So, what was required? Was it written in Python, or yeah? So.
Just a second. You need to know React, you need to know NPM and TypeScript, and maybe web.
And did you create it yourself, or you just found it somewhere in GitHub already available? So are there any custom visualizations already available? So
another developer gave me HTML page and JavaScript code which can create this visualization. If I run HTML code, I saw this visualization, and I needed to implement this chart into Superset. Here is a hard-coded values, but I needed to change these values from Superset. For that, I created a hierarchy bridge in SQL. I created an additional table with hierarchy bridge and got information from this table and populate this chart. I cannot show it because it's NDA.
Okay, understand. Okay, yeah. Thank you very much, Dmitry, for your presentation. Very interesting topic and tool. Yeah. So next talk is in 20 minutes. Please stay tuned. It will be from Izabella Zuk about non-production story about how to make your data project successful. Yeah, stay tuned. Thank you, Dmitry.
You're welcome. Goodbye.
Hello everyone. This is Winter Data Meetup from Zen Community. Our speaker is Izabella Zuk, and she will talk about the non-technical problems she faced while working on different data projects, and about approaches that will help to make development process smoother. Please don't forget to ask your questions in YouTube chat. Hi Isabella, it's so nice to see you here. I pass the word to you.
Hi, hello everybody. Nice meeting you. I'm very glad I can have an opportunity to share a bit of my experience with you guys. Let me move on to the presentation then. As you already mentioned, the topic for today's presentation are non-technical factors of data project success. Maybe before we start, a few words about me. So I'm currently a senior software engineer in EPAM. I come from a kind of interesting background because I started my career as a data analyst, having education in statistics, but also I have a BA in international relations, which is more of like a soft skill topic. So I've been already working on data projects for over 5 years, four of which I've been working in EPAM, in various team setup in multiple roles, first as a data analyst, then as a data engineer. In terms of my personal favorite things to do, except working on data projects, of course, I enjoy good food, and basically I love cooking and all the sport activities that you can do outside. Most recently, I think my favorite one is hiking, especially friendly to do during the winter. I find myself to be, I think, kind of a good observer and a people person. That's why I would like to share some of the observations from my experience with you today. Regarding the agenda for today's meeting, I think I'll try to keep it fairly quick with an introduction of a few slides with more of like high view approach. This is why is client not always right. We're gonna talk a bit about how to understand the bigger picture and the final product across the team in the project. I'm going to talk a bit about non-technical factors that can influence the success of a data project. And then we're going to move maybe to more like specific topics with some actual hints that I would like to provide that you can start using while working in the different team scopes after our meeting. We're going to talk about how to achieve the synergy across various team members with different seniority and different roles. We're going to discuss about clarity in terms of communication. And last but not least, I would like to present some nice framework to communicate during some crisis situation that can actually come in handy with your day-to-day work. And after that, hopefully we'll have some nice time left for Q&A. So please feel free to ask me a question. Okay, so real quick, let's move to our first topic. I added this kind of perky title, why is client not always right? But what it's really about is that why it is important to understand like a bigger picture and the final product, the final creation that you try to achieve as a team. And this is important for each and every role. So whatever is your current role on the project, whether you're data engineer, data analyst, data scientist, data quality engineer, I think this is important for everybody. So let's start from like the most basic thing, which is a task. Oftentimes, when we try to analyze the task that's been given to us, we always need to know what we need to do, obviously, right? When we need to do it. So what's the deadline? What's the time estimation? What's the priority? How we should do it. And this is basically where most of most technical roles will put a lot of focus on. Yeah. So what technologies to use, how to set up that feature, how to integrate it within a framework, maybe we need to create it, what technologies to use. So these are the things we put a lot of emphasis on. But sometimes we miss the why part. And the why part here is basically how to place your task in like a bigger system of what the project is trying to achieve. So it's always, for me, good to ask yourself, what is it really going to contribute to? A good example here can be that you're trying to build some sort of an ETL that will deliver data from point A to point B. And the point B is then going to use by who is the stakeholder, like where are we going to use it? Maybe if it goes to several Power BI reports, maybe there is something I can improve, or there is some additional risk I see. And the why part gives us actually ability to make better suggestions and better comments. Why making suggestions and comment is important when we actually discuss a task and try to understand what to be done. Many times people who plan things on high level, they don't see like the lower structure. And sometimes developers or specialists in general are afraid to speak up about some potential suggestions. For example, they do see a better way how to do a particular thing, but they're kind of afraid of sharing that thought. Or maybe they cannot come up with some better recommendation because they don't see where are we actually going into. A good example might be that you're trying to develop some sort of a feature, for example, and then you don't know that couple more steps in the roadmap, we actually need to deploy this particular feature, for example, to some other application. Maybe there are already some things we need to consider at the beginning when coming up with the initial design. This is some simple example. And another conclusion from this is that the more time we actually spend in trying to understand, well, what and why we need to do, the better time we can spend on planning. And better time is not always more time. So to make planning like efficient and to really be able to come up with a good solution, in my opinion, it is very important to understand the bigger scope to be able to make those good suggestions. And what is important is that I think that the most successful teams, not only in terms of data, but in general, will be the ones when the specialists and people who will actually put in the work to complete the task are also participating actively and not only when specifically asked. Okay, so now let's move briefly to non-technical factors which we need to consider when we are working on a data project. First one is kind of obvious. This is the team structure. What seniority do we have? What roles do we have? And what previous experience we have within a team. Some things to consider more to like data-specific projects is, for example, the clear definition of roles. I worked on a couple of projects in my career, and I worked both, as I mentioned, as a data analyst and then as data engineer. And for me, oftentimes it seemed a bit fluent. On one project, some responsibilities came in the scope of, for example, the data scientist, but on a different project, they were already part of a data analyst. And good planning here can actually bring a lot of benefit. In terms of seniority, this is kind of obvious. Yeah, right. We have more junior and more senior partners, and this is good to have like a framework to cooperate. International project considerations, time zones, and languages. Regarding time zones, from my experience, one thing was worth mentioning here is that when you have a team with a lot of separate time zones that start working, for example, on a different time set, it is important to divide responsibilities well within a team. On one of the projects, we had a setup where we had some of the colleagues working in one time zone and some of the colleagues working in another. And what ended up happening at the beginning is that really the cooperation and meaningful work came only between those 4 hours of overlap that we had. And with time, we managed to actually use this time better because, for example, some of the ETLs that run through the night, the team that logged in first started on some initial bug fixes of initial identification of what potentially could go wrong with the ETL run of the night. And already on the daily, when all the team was logging in, we had some, you can say, report on the situation. And the team that was staying later was more responsible for like communicating to customer who was in a later time zone. And that's how we divided the work. So that's also something you can consider. Roadmap. Roadmap is connected to planning. And here I think everybody would agree that when starting a project, it's important to have like clear goals and clear milestones and make sure that everybody understands where the project is going. This is connected to what I was talking on the first slide, but I cannot stress enough how this is important to actually come up with like a good solution. Next thing is support within a team. That's a bit connected to the synergy. So here it's important to know how we will remove potential blockers, who can help with what, and how to ask for support. Many times in my career, I've seen a situation when one of the team members was working on some sort of an implementation or some sort of a report, and he or she got blocked with some particular problem, but did not know who to come for help and did not know from where to get knowledge in terms of that blocker. And sometimes even the clarity of communication on the daily stand-up that most of the projects will have nowadays, he or she was not able to remove this set of blockers. On the other hand, what also happens a lot is that you have most experienced, most senior member on the project, and then all the questions from other team members, maybe more junior or just simply less experienced, will come to that particular person. In my opinion, that's not also great, and this leads us a bit to the next part, which is creating the backup plans. In order to avoid the situation when we get very blocked with something and the person who's less experienced or simply junior in some topic does not know where to reach help, or at the other hand, when we get the more senior and more experienced person overwhelmed with a lot of questions and a lot of responsibility from all over the place, what is important is that we should always keep good knowledge sharing within the team. And that seems obvious, but honestly, every time when I was working on a bigger data-related project, and I think that's true also for any other project, not only in data, we had a situation that if one of the key members of the team either quit or simply changed the project or went on a longer vacation, we faced some problems and issues with proceeding with development or even supporting the current solution. So knowledge sharing is very important, and also something that I think personally I always cheer for that on the project that I work in is participating in releases. So knowing what exactly is being released and knowing who could be contacted with each part of that. Oftentimes when a person is closed in a silos and is working only on her or his particular task, he can lose track of what is being developed at the same time on the platform. And who knows, maybe there is something you can reuse, maybe there is some good idea that you can put into your implementation, or maybe there is some condition that will actually influence what you are working on. And when you're tracking what's happening on the platform, when you're working on your report, feature, or your model that's supposed to predict something, that way you can come up with like a better and more comprehensive solution. Another thing is how to manage the risk. So oftentimes on the projects that I work with, we had some sort of a critical product that was delivered to the business or some stakeholder who then needed this product to perform some either business decision or some other action that's important for the business. Many times a person notices an issue but does not really know who to report it to, and is that issue really critical? So I think what is important on a data project is knowing how to identify that the issue is critical, which leads to how to identify that the service is critical, and then knowing how to approach issues on different environments. For example, the issue on production should be communicated in a specific way to specific parties, or maybe there are several reports that your team is supporting that are critical over all other reports, and they should be addressed immediately with some particular severance. This seems very obvious, but in reality, on a lot of projects, these things get kind of lost lost in the communication. And I think this one will be especially true for some legacy projects. And another thing, this one I think we all know, is putting a realistic timeline. So always the person who is actually going to work on the task should participate in estimating it. What I've often seen is that more junior or less experienced colleagues were given a task that was estimated by their senior colleagues, and then we had a problem with completing sprint within the scope. Or from the other hand, it can go also that a person who is more experienced in some field will finish a task much faster. Okay, now when we have all of those considerations, let's move to the synergy in the team. So basically what is synergy, if you don't know, or we would like to kind of put it into perspective, it's the situation when the cooperation of two or more organizations, substances, or any other agent can produce a greater effect than all of those separate effects summed together. So within the team, in the data project, you have usually a lot of different roles. You have data engineers, you have data analysts, you have business analysts, you have data scientists. And the first step of achieving this synergy is having these roles well defined. So each of the roles should have some sort of a particular expertise. An example, a data scientist's main expertise is developing prognostic models, right? So they mostly deal with maths, they deal with building models. Not necessarily they need to deal with some sort of data automation. And this leads us to sharing the skill between those roles. We should use the help of our colleagues, even if they're from a separate role, to unblock if needed, so then everybody can focus on the expertise. What I experienced, and actually more than once, is that a colleague who was working on some either data analytics or more data science focused task got blocked for several number of days with some connection issue or some sort of a problem with some automation or some small ETL he tried to set up to test his model or train it. And in situations like that, a lot of time and effort can actually be saved by asking colleagues from the other roles. For example, ask your fellow data engineer to maybe either develop some simple framework that you can use on your Jupyter notebook, or maybe figure out how to solve the issue with authentication that you've came across. And it also works the other way. Maybe you in your work as data engineer need some help from a data analyst to validate, or maybe you require some suggestion what would be the best schema to put the data into. At the same time, I think it's important to take time to enable your colleagues. So oftentimes what I've seen on the projects is that different roles worked in some sort of silos. When I worked as a data analyst, I started my career and I was still like a junior data analyst. We, within the analytics part of the team, used to waste a lot of time. We used to spend a lot of time on trying to automate things. But then it turned out that it would save us a lot of days, a lot of weeks of work if we would have a data engineer in the team who would actually help us set everything up. And right now, when I, on my previous project, work as a data engineer, we actually were able to provide some enablers for our data analytics and data science colleagues for them to use within their work. So it actually allowed them to focus on what they do best. So analyzing the data or building some models. And also the last thing, I think it's important to always consider your shareholders' opinion across the team to make a smart solution. If you're developing an ETL that's then that produces the data that it's supposed to be used within some prognostic model, I think it's also always good to touch base with your model building data science colleague to discuss about maybe there's something special he or she should think we should include, or maybe there are some additional considerations to make this solution as smart as possible. Again, working within those strict silos can actually sometimes lead to some inefficient work and not ideal using of each person's expertise. In order to achieve that synergy, there is one key thing that actually is oftentimes not that obvious on IT projects, and it's communication within the team. Especially now when we work, most of us works remotely, and our team members are located in a lot of different countries and a lot of different time zones. It's sometimes hard to keep like a clear communication. And in my opinion, of course, in terms of non-technical aspects of a project, clarity and clear communication is a key to quality. So why communication can be not clear? First thing is that the message can be too long. So the real message can get lost in a lot of gibberish that's been sent. The message does not have proper recipients. So the message is correct, but then the people who are receiving are not actually the ones who should. The message is not stated clearly, so there's some vague explanation to it, or it's not stated at all. And that is actually, I would say, most of the contents that I've seen, that someone was either afraid to speak up or he thought that it's not needed to do so, yeah? Such as you could ask a team member for some help, but you decide to spend a lot of time or resolving some problem by yourself. And the last thing, there can be some other obstacles to communicating the message. And one thing I had in mind here is that a lot of times when cooperating with a client or non-technical party, engineers or analysts will try to, specialists in general, will try to deliver some very specific technical details. And that can lead to misunderstanding of a problem. For example, to ignoring like the real weight of it. So it's important to identify this potential obstacle and actually try to adjust a bit the way you communicate to a proper recipient. So for example, to your technical colleague, you will speak with more technical details about some problem, but to a client party that not necessarily has all that knowledge, maybe you should keep the information more high view. And again, this seems obvious, but actually I've seen a lot of times that this was not working properly. So there are some benefits of this communication that's clear. For communication between team members, this is again helping achieving synergy in the team. It removes blockers because if we communicate them, then we can remove them quickly. And what I believe is that we share ideas, we improve our ideas. So it's not always good to stick to just what you think is best. Clear communication can lead to improving your implementation. Between developers and business stakeholders, I think this is kind of important. We forget about it, that if we communicate on what is going on, then we show some sort of dedication, we show that we care, and also we eliminate a lot of uncertainty. So for people who are more of like a business end of a process, I get the feeling that they sometimes have this feeling of uncertainty with the technical process, what is going on. And if we try to communicate with what we are progressing, what's the status, then it actually can lead to better relationship with your business stakeholder. And between devs and BAs, here can be a similar situation. So I think it's important that the devs participate in curating stories. It leads to clearer definition of the tasks and better evaluation on time spent. And also the better the BA can understand like the potential technical blockers, then the easier it will be to communicate it to the business. And here's some practical tips I decided to put in terms of particular types of communication. So first, it's the email. In terms of text, very good practice, I think, is to either underline or like make bold the part of the text that you want person to see first. I think it's good practice that if you actually see an email within the first 30 seconds, you know what's there and what's the important parts. If you really need to write a long email, good practice, I think, is to summarize the message in 1 or 2 sentences at the beginning and then put all the rest of it below. So the party that sees the email can decide that, for example, okay, I don't need to read it now, I can go back to it later. And review the recipient list. Only the necessary contact, I think, should be put in this email because oftentimes people tend to play less attention into emails that have like 300 people included. In terms of speaking a call, always try to set the goal and agenda of a meeting if that's possible, because then it's easier to determine who should join and for what purpose. And avoid long monologues with complex issues. That's exactly what I'm doing now, making a long monologue. I'm sorry. So it's always good to catch attention of your listener. For example, ask, what do you guys think? Am I being clear? Like, to avoid speaking for a long period of time and rather try to interact, even if that's a simple question. And again, review the attendance. Something I learned the hard way is that if there's a meeting with a lot of people on it, oftentimes people are less happy to share their opinions freely and are less glad to actually discuss with open mind. And general, something that saved a lot of things when working on a project is that even if you see a problem with some sort of implementation, or you don't like something that's been done and you do not see a solution to it yet, it's always good to raise that problem, because maybe someone else will come up with a solution. Maybe even like noticing the problem can already bring some benefit, and then you can brainstorm or come up with some solution to it. And if you have a suggestion on implementation, it's always good to let the person know, but it's important to respect other people's ideas. What I've seen a lot of times is that people were actually not very kind and polite when commenting on other people's implementation. And I think that's very not okay. You should always consider someone put work into this implementation. Of course, you have right to criticize it, but always remember to make it respectfully. Maybe sometimes even it's good to make some sort of like one-to-one suggestion. And don't wait too long with communicating issues and blockers. This is something I've seen a lot of times, that the issue happened 10 minutes after daily and the person waited next day to communicate that he or she has a blocker. That's also not great. We should usually inform about this stuff earlier. And actually, this is kind of connected to this knowledge sharing and communication framework between different seniors, right? So let's say that you have a go-to person that you would talk to first, and then you communicate the blocker. Or maybe there is some common chat where you can inform and ask for some help or some consideration. Okay, and now the final part, some advice on how to communicate when there is a problem. Let's say that you notice that there was a bug in your implementation. One of the ETLs failed. The report that client desperately need at 7 a.m. is empty. This happened to all of us a lot of times. So first thing, how we should communicate during this crisis. And this is coming from my experience, but also coming from a lot of like communications study and courses that I did at some point. And for me, the biggest simplification is to do it quickly, clearly, openly, and progressively, and what all of that means. So first of all, quickly. As soon as you notice that there is some issue, I think it's important to send out some sort of a first information. And we will go through some examples in a moment. Clearly, once we get exactly some more information on the issue, we should notify what is the problem and also what does this mean. And this is connected to communicating things to people who are not necessarily technical parties. So yeah, you can say that, yeah, the service is down and this means you will not get this report at 7 a.m. Then what could cause it? Who will fix it? Is there any help needed? Things like that. So just communicate clearly, more details. Also, communicate openly. Oftentimes, those issues that we face on production will result from some sort of a mistake. It can be a human mistake. And I think to build like a trust and clear communication within the team, it's good to say that, yeah, that was fault of, like, for example, say there was my fault, or there was a fault of this or that specific factor. And I think that open communication is actually good practice, because we all make mistakes and we all learn from them. And then progressively, this is very important. So once we find the root cause and once we fix it, what we will do or what we've already done to avoid this from happening. Yeah. Maybe, for example, we should add some unit tests. Maybe we should work on our CI/CD. Maybe we should review how we do a PR, or maybe from more like analytical perspective, maybe we should design additional metrics to the report. Yeah. And here I put it into actually steps, so make it better. First is first information, then detailed information plus ETA. So already in the second information, we should provide where we plan to solve it. Then if there's needed, and most cases it is, update to an ETA. And the last thing is like the resolution email and precautions taken with time. And this can take two phases. First is unofficial communication. This is usually like Slack or Teams. And this is example of messages that I wrote as, I would say, like junior member who is notifying his team leader that, hey, I found a problem and yeah, like we're gonna have an issue. So first message is the first information. Hey, how's it going? Was checking some events from service X. Seems like we have nulls in the field Y. This is completely, dummy example, but I am checking what's going on. Reporting can be affected, so let's let them know to watch out. And this already, even though you see there's not a lot of information in this communication, I found that it's still very beneficial because it already raised a flag. There is a problem. We're investigating this problem, like raises awareness. Maybe we should notify someone. The second information is detailed information. I found the issue. It's my fault. I made a mistake. And this is again the clarity. In the column mapping in job Z when working on ABC feature, I will fix it in 2 hours and send for review. So here we have ETA. Of course, there is some problem and the ETA gets elongated. Seems like there were some problems in my initial solution, need another 1 hour to finalize it. So this is step 3. And step 4 is the final resolution email or message. And here in unofficial communication, it can look like, okay, I fixed the issue. Here's my solution to review. I added additional unit tests to make sure we'll avoid that in the future. So this additional unit test part is for taken precautions, which actually I think is a very good thing because it shows that we did not ignore the issue. So that would be for unofficial communication. And what is very important is that the update on the ETA should always come before this stated ETA is there. This is especially important when your project is working on something business critical. And the asset that you're delivering is very and critically important. So a lot of time this will build like confidence that you understand the necessity of informing when the data will actually be delivered. And this is a similar example, but this time this is more to like official communication. So for example, if for some reason you need to communicate to your business party, then you can use this framework. So here we identified an issue in service X. The data resulting from service X is not safe to use. Affected reports are A, B, and C. We are working on identifying the root cause and establishing ETA. So this is a message that you would send when you know that there is a problem, but not yet exactly what is the problem and when we will fix it. But it's important because it shows that you're actually working on the issue and that some sort of it's under control. The second part, our developers have identified the issue. It's connected to human error that went unnoticed during review. Data in reports A, B, and C is not safe to use. ETA is for 2 hours, and you can also provide time zone because a lot of people working in different time zones. It's always good to provide like that. We are working on resolving the issue due to some problems we face. We need to update the ETA to 12. And the final mail, issue is resolved, data and reports A, B, and C safe to use. We implemented additional unit tests to avoid such problem in the future. Sorry for any inconvenience caused. So that is the framework that I've been using and I've learned from people who I actually worked with on the data projects. And to be honest, this is something I swear by when communicating crisis management, because oftentimes when you're stressed, and there's a lot of things going on and you don't know where's the issue, you need to investigate and so on. It's very easy to get lost in this communication. But then the clarity and like building trust with this sort of communication will actually bring a lot of benefit to the team. Okay, so that would be it from my side. I will end my very long monologue and now I will, give back the word.
So now you're ready for questions, right?
Yes.
I thank you for your talk. I could totally relate to this knowledge sharing problem that you highlighted. And there is a question in our chat. What are the best approaches for knowledge sharing inside the team with many newcomers? What is your opinion?
Mm-hmm. Well, so I think very important part of that is, especially with a lot of newcomers, is to having some sort of either documentation or for example, what is very good in my experience, some sort of recordings, for example. Every data-related project will have some, common introduction that you need to do, yeah? There will be a common part that needs to be done for each and every role, and then a specific introduction that can be done separately, for example, for data engineer, separately for data scientist, separately for data analyst. If you will have some pre-recorded sessions, the specific for each and every role, then you can actually save a lot of time of the person who's giving this introduction. And usually the introduction is been given by the most senior and most experienced and also most busy person. So how I would suggest to do that, and this was something I introduced in 2 of the projects that I worked in, was to have like sort of a cheat sheet for knowledge sharing for newcomers. So you can have some sort of videos or pages on Confluence, and you should list them in the order. First do this, then read this, then watch this, then do that. And to a specific extent, they will actually be the same per each role. But after reaching certain level of knowledge, then there should be specific onboarding for data engineer and specific onboarding for, let's say, data scientists, right? Because they work on a bit different tasks. But another thing I would suggest is that there should be like an owner within a team who already works on a project on onboarding the newcomer. So the newcomer is usually, a bit overwhelmed, especially if that's more junior colleague. And he or she should have like some sort of a buddy. This is a bit of a corporate word, but someone to go to and ask questions. Even if this person is not most senior and will not be able to answer all of those questions, let's say he or she will be able to answer the half, and the next half only can be routed to some team lead or senior member. So this is for the newcomers, I would say. Come prepared.
Thank you. And about the last part of your presentation, you told us a lot about communication. But what if recipients are correct, questions proper, but there is just no reply for some reason? Maybe the recipient is too busy, or maybe he or she just doesn't want to handle my problem. What do you suggest?
That is a very good question, actually, and that is also what happens a lot of times. So I would say first thing is that it's more for like maybe project manager thing, but it's good to think why it happens. Maybe this particular person is having a lot of knowledge, or maybe all the knowledge in particular field, and has simply too many tasks. For example, he's working on critical feature, he's communicating with business, he's onboarding newcomers, he or she, and simply there is no time to answer the question. And here comes the knowledge sharing. So what I think, there should always be more than one person who has some knowledge in this area. So then we will not end up with one overloaded person answering all questions. But if it's too late and already we need to get an answer for a recipient that's not replying, honestly, I would not hesitate to wait. Well, like the business convention is to wait 24 hours. But if that's critical, I would not even wait that long. And I would politely come back and ask. For example, if it's a message in Teams, I usually do it like, hey, do we have an update or this? Or maybe there is some other person who I can contact, yeah? This happened a lot of times to me, that actually I was pointed into some other direction from this person. If it's more serious business communication, that I would suggest to work 24 hours and then politely ask for an update. And unfortunately, if there is no reply after some times, then it's probably to be escalated if you cannot resolve this question by yourself. But this situation actually means that the communication and like knowledge sharing within the team is not working properly, because it means that the person is probably overloaded. And there was also mentioned, what if he or she does not want to answer the question? Yeah, that's a very specific situation, I think. So yeah, here maybe there's a good way to ask that person, like after several asking for updates, maybe, I don't know, he does not want to help out with the particular problem. But yeah, I think It's never a problem to ask for an update, especially if it's like less official communication. I would not hesitate to do that.
Yeah, thank you very much, Izabella, for your presentation. It was really interesting. Yeah, so next speaker is Kassiyet. So she will tell a really interesting story about her migration to DataSphere. So yeah, if you're interested about joining DataSphere, so please. Yeah, thank you, Izabella, one more time. So see you.
Thank you. It was a pleasure.
Sorry, Alexander.
Hello everyone. It is Winter Data Meetup from Zen Community. Our speaker is Kassiyet Topysheva, and she will tell us about her transition to BI analyst. Please don't forget to ask your questions in YouTube chat. Hi Kassiyet. It's nice to see you here. I pass the word to you.
Hi everyone. Thanks for joining. So my name is Kassiyet. I'm a BI analyst at EPAM. Today, I'm going to talk about how did I transition to BI, and will share my experience in transitioning to BI. Yeah, so let's get started. So here's a brief information about myself. I have over 10 years of experience in IT. So before I worked as a business analyst, about 8 years on digital transformation projects in public sectors. And over the last 2 years, I have been working as a BI analyst on data-driven projects. So my educational background is software and hardware for computers and network specialist, and Master of Science in e-business management data science stream. And here's the agenda. I will tell about what did I do before becoming BI analyst and my path toward data and BI. So, and why I changed my career path, what steps I took, what is my current role and job tasks. Yeah, so the first question, so what did I do before becoming a BI analyst? So here you can see one of the main tech companies where I worked as a business analyst. So in the first company, I started my career job as a business analyst. So it was about 12 years ago. So at that time, business as well as public sectors had started automate their business processes. So they started their digital transformation, and it was a bit challenging to work as a business analyst because there was a lack of resources, trainings, courses, and in the most case I had to learn by my own. So the first project was about automation of post-customs risk analysis process. So, and for the first time, I communicated with stakeholders, gathered the requirements, and draw UML diagrams, prepared software requirement specification documentation. And luckily, it was a successful project, and I started to enjoy this business analysis job because it was interesting to me to examine the business process and transforming the business processes from as is state to be. So finding the optimal ways. So in the next companies, for example, in the second, the client was the Minister of Finance, and they carried out a large-scale digital transformation using SAP products. And I was involving in several projects where SAP modules like CRM, Solution Manager, Business Warehouse, as well as business objects were implemented. So thus, I worked as a business analyst in other tech companies performing the business analysis duties like business process analysis, requirement elicitation, CRS documentation preparation, UML prototyping, and here's in the second slide you can see some of the artifacts that I created. I prepared in my business analysis job. So it is quite interesting because working as a business analyst will help you not only to know and learn about a software development process, but also you'll be able to know the subject areas, the domains that you are automating. So why and when I changed my career path toward data. So it was started from my dream. Well, when I was a student, I had a dream to study abroad, to get master's degree in IT. So to follow my dream, I applied for the scholarship, International Bolshak program from our government. And luckily I won the grant and I had a chance to study abroad. So definitely I was looking for courses, programs related to in IT. And among the programs, I chose master's study e-business management. So it has 4 streams, specializations like e-commerce, digital marketing, data science, as well as digital consultancy. So to be honest, in the at the time, I didn't know well about the data, like a data science area, but I had the research and I understood the importance of this data area, and I had some consultation with the people who studied on this program, and I chose this data science specialization. So it was at the University of Warwick. So in the next slide, you can see the key modules of this program. The first one of them, it was computational statistics with Python. So I can see that at the time I didn't know well about the Python, but before starting this like a module, for 3 days, I learned the Python because it was written by my professor in an easy way that you can. I was able to learn easily. So within this course, we created the data pipeline that automates the data cleansing, data transformation, the initial analysis using raw data. For big data analytics and the visualization, we created the analytical reports, data visualization on Tableau. And for data science and the machine learning, which was one of the challenging module. And within this module, we build predictive models using machine learning algorithms. And for cloud native computing, we created CI/CD pipeline in AWS cloud technology. So there are other modules that I took within this program. I have to say that it was challenging to me, but thanks to this course, I realized that I enjoy solving tasks and even coding, even it was new for me, for example, Python. And I was thinking to shifting my career toward data. And I think one of the factor that's that helped me overcome these challenges, I think the professors and the tutors of this university, of this course, because they were capable to explain the hard technical subjects in an easy way that even non-technical students were able to study on this course. So luckily I managed I completed this course successfully. And so after completion of this course, I was looking for a job, and I was hired by one of the big tech companies of Kazakhstan, BTS. And in this company, I was involved in 2 projects. So the first project was development of analytical intelligence system for procurement, and I was responsible for the ETL part, and I need to design a functional architecture of ETL. So I designed the functional architecture of ETL process. I also documented this process. Also, I participated in the automation of ETL in low-code platform Logino. So you can see here the UI interface of this platform Logino. So as a result, the ETL process was developed successfully, and pass to the next stage. The next slide, there is a second project where I involved in. So the second project was more technical. So it was exploration and the analysis of procurement data to find the insights, to find the most influential factors to anomalies. So within this project, I was like given a task to explore raw data to find the most important factors affected the target feature. So what I did to fulfill this task, I did analysis in low-code analytical platform, and I implemented the methods of descriptive statistics as well as machine learning. And I built models using algorithms like decision tree, random forest, and clustering methods in Python. So as a result, I found the most important factors that affected the target feature. So I have to say that this project, this task was very challenging because I had a lack of hard skills, especially in statistics, in like machine learning, and I decided to take the like a proper course that helped me improve my hard skills to fill in the gaps within these areas. So then I found a very good very good program course, which is called Data Analytics. So it is from Karpov courses, Data Science School. So this course consists of the modules like Python for data analysis, SQL, statistics, visualization, and other modules. And it lasts for about 5 months, and I enjoyed very much this course because it helped me to fill the gaps that I had for example, for Python, for statistics, and I enjoyed this course, and I become more confident in these areas. So then I joined the EPAM, so 2022 March, and EPAM was one of the like a dream companies that I wanted to work. And coming to the CPAM, I had also took courses and trainings like related to data modeling, database, data warehouse, cloud concepts, ETL, data visualization in Power BI, as well as data storytelling. So here at EPAM, there are so many opportunities to improve your soft and hard skills. And so currently, what is my current role and the job tasks? So I'm working on the project. This is my second project, and the client is the largest IK device company in the world. So it has its branches in more than 140 countries, and the project is big data analytics platform, data lake, which is like implemented in cloud platform AWS. So my role in this project is data and the business analyst. So what I do on this project, so in terms of BI, business intelligence, I do data discovery, source data analysis, source to target mapping, data modeling, data verification, mostly in SQL. So in terms of business analysis, I communicate with stakeholders to gather to manage the requirements, and preparing the project documentation, facilitating the of Scrum, Kanban processes, and for UAT writing test cases for dashboard and the data validation, and also demonstrating the project deliverables, project outputs to the stakeholders. So what are the next steps to grow as a BI? To be proactive in my current project activities, successfully drive the projects, and to improve BI analysis skills in data profiling, data modeling, data visualization. Also, I'd like to gain the cloud certificates, especially in AWS. And also want to involve in data science projects, because it is very interesting for me, this area. And from my journey, from my experience, I highlighted some takeaways. So if you are considering shifting to data area or BI analysis, you can try to learn SQL, querying data, or visualization. For example, one of the BI tools like Power BI or Tableau, maybe some coding with some programming language, maybe with Python, which is popular in data science, data area, as well as statistics. If you feel that you can you enjoy some of the areas, some of the activities, you can consider maybe shifting to BI world, data world. And also, of course, when you you put some effort, for example, on learning new things, of course, you can face with the challenge, but don't give up whenever you face the challenges. Take step-by-step actions. So, and other recommendation that I'd like to give, to follow LinkedIn. So you may know that LinkedIn has a large a number of professionals, especially in data. So you can connect as many people and communicate with them. And be curious. Be curious when you when you are interested in this area. Try to learn up-to-date information about data. So this is my few tips for you. And this was the last, I think, slide. And if you have questions, I'm happy to respond to you. Thanks.
Thank you, Kassiyet, for your talk. It's really, impressive. How much did you go to get to your goal? And but in the very beginning, why do you like data sphere? Why have you chosen data field? What was your motivation?
I understood that. So as I said in the beginning, I didn't know well about this data world, data science. Even I was very scary to choose this specialism, data science. But when you go through something, when you, for example, when you study, and you can realize, do you like this new area or not? So for me, I found that I realized that I enjoy solving tasks, and even coding was very interesting for me. And I overcome my fear. I overcome my barrier. So this course helped me to choose this area. I can say.
So it's more like you tried it and you liked it, and then you pursued your career in this field. And about this, looks like you are ready for data science. Why have you chosen BI? I mean, why didn't you go further?
This is interesting. So I told that in my previous company, I was involved in the like a data science, machine learning projects, so related to machine learning. And yeah, it was interesting, but at the same time very challenging because of lack of like hard skills that I had at the time. And yeah, when I like joined IPAM, there was a like an option to choose BI analyst. But about data science, I at that time I didn't like searched for if, for example, if there are like opportunities at IPAM. And coming to the IPAM, being as a BI analyst, I yeah, I like I realized that it is with that job that I can like enjoy, because it combines the skills of business analysis as well as like data analytics. So but in the future, yeah, I'm as I've said before, as my like future steps, I'm considering data science, because I'm continuing to learn, to read the books about this machine learning. And yeah, yeah, I will consider it.
Yeah, so you are not going to stop, right? So from you have listed like a lot of resources and a lot of courses that you took, but what is the most essential technical knowledge that was really useful to move to BI?
Yeah, this is a
Like,
good
was it
question.
math, statistics, or was it SQL? Or
So, the courses that I took during my master's study, and the course from Karpov course, the most of them related to data engineers, so data scientists, because it has, for example, Python for data analysis, for example, statistics, for example, A/B testing. So most of these skills like implemented in data science area, and data being as a data engineers, for example. And so your question, one of the what about BI analyst, what was the most
yes,
useful
essential.
skills? Yeah,
Yes.
essential. Yeah, was SQL for me, and Python, and data visualization. So of course they. You are asking in terms of BI, yeah. So these two areas was very useful in my current job. Yeah. Sorry. Yeah.
Maybe some connection issues. Sorry. So that was exactly what I was asking. What can be first steps for those who want to become BI?
So first steps, for example, if the person like me was working as a business analyst, maybe first steps to learn SQL, to learn data modeling, to learn what else? Python, maybe not very like implemented in business analysis job. BI analysis job. I'm confusing at the sometime. Yeah. So I think, yeah, this is data modeling. For example, when I worked as a business analyst, I like draw diagrams, like object diagrams, class diagrams. So these skills, I think, are more useful when you work as a BI analyst, business intelligence, because you are working mostly with data, with the data structure. You need to know the relationships, for example, between tables and yeah, data warehouse. Yeah, about data warehouse is the one of the most useful topic to know, yeah, for BI analysts.
Oh, thank you. Thank you very much for your talk. That was very interesting to learn. Thank you for sharing.
Yeah,
And
it's my pleasure.
and thank you everyone for watching. And our next speaker will be Mark, and he will be talking about data mesh. It will be like in 15 minutes. So stay tuned.
Thank you.
Thank you.
Bye.
again, everybody. And now our next speaker is Mark, who will tell everything about data mesh. So, Mark, passing word to you.
Oh, thank you very much. Happy to be here. Good day, all. Thank you very much for joining the session. My name is Mark Makary. I'm leading the fast data service offering within the EPAM data analytics practice. We focus on real-time solutions, event streaming, modern data platform, and we work across different business domains with different business use cases, not just for telecom or IoT space. We work with manufacturing, retail, insurance, financial, health, and logistics, just to name a few. And working with such wide spectrum that provide us with wealth of experience in that space, and of course, happy to share some of that with you today. So the data mesh, I think it's really generating a lot of hype around the concept, but somehow it seems that we got lost in the what or what it is. You know, and we really can get a better understanding of the what and how. Of course, when you take a step back and use the power of why. So if there's really one thing that's not going to be disputed on my talk today, I think it would be the slide. We have a lot of significant business value when it comes to data and analytics. It's essential for the enterprise, essential for surviving in today's world and today's market. When you have someone competing against you and they have a crystal ball, you know, like predictive analytics, it's a problem that you have to work hard to match that undisputed advantage. And it's not just on the competitive advantage, it's also on cost reduction or generating revenue, new revenue opportunities. Also, it's very important aspect when it comes to risk reduction and security. So, you know, having really those use cases in there that, you know, I don't want to go through them in details. I think that everyone agrees this is really of significant business value and nowadays. So we have a lot of challenges really in the data space. You know, it's not just the volume coming in, it's the complexity of the types of the data that coming in, also in the formats, and also the supported use cases. You know, a lot of this really challenges helped us with the data, with the opportunity for the data platform. So you see the rise of data platform to meet those interesting market demands and opportunities. And we have different approaches in there. So as you can see, we started with the data warehousing using the ETL approach, or you know, which is ETL or ELT. You know, where we have the data lake, which is more suitable for machine learning and analytics. In any case, we usually use the Lambda architecture for that. So we have operational data coming in or analytical data coming in that we store those in temporary placeholders, and we run batch processing on top of that with ETL and ELT, and then we send it to our data platforms where it gets processed in there. However, with this existing, and also we have the hybrid actually, which is a mix of data warehousing and machine learning. Having said that, there is some characteristic that actually common on those approaches. So you'll find out that we focus a lot on the batch side. So our procedure usually is not in a timely fashion. It's untimely, where we have few stops. Also, it's a centralized approach. So we usually use monolith, centralized data team, and centralized data platform. And most of the time, that all the processing on the data analytics side that need to run there. We also have the notion right now that of accepting because business value for our data set. So we really care more about not missing out on those data sets. We would have them in our storage anyway, even if the business value is not well defined. And we sometimes that we usually have to strike a good balance between governance and usability, but sometimes that we actually let governance take over usability or the other way around, and this is really a challenging aspect in that space. So having those characteristics that lead us to talk about a couple things in terms of pinpoint, in terms of why, on really the challenge to unlock the data value. So we run with challenges on the data quality side and the data availability. So as you can see, those platforms that they are successful to some extent, but still run into issues on those two fronts. And just going to use those two for today, but there's more, but I'm going to focus only on the data quality and data availability issues. And again, we are really caring more about not missing out on the data. So you started collecting everything, and it seems the data lake really became like more of a swamp, and it's getting harder and harder to extract useful data from there. I remember as an example, one situation that at one point someone collected shipping label as an images to support product geo reports, finding strength point in terms of the geolocation for a specific product, and thought this is really an easy way to do that by just collecting the images, and somehow that they forgot to attach the shipping labels to a product, so we don't know what those images for. And and on top of just using this kind of format and missing out on relationship, we named it, or it was named as just a label instead of shipping label. So it's not really identifiable, not complete, not searchable, not usable in any way. And I guess all of you that at one point that would run into this one way or another. And another important aspect also is not just on the data availability side, is not just the access and the availability, it's a timely access. It's very important too. So we run into issues, with our point-to-point feeds in terms of negotiating that I need to get this, I need to get that from the source, and we have really slow time to market in there. Also, ease of access is an important aspect. So you'll find out a lot of the times that we find out that it's a data is available, but there is a very complex process that we need to go through to get to this data. So that, of course, would lead us to data mesh. Data mesh to the rescue. So as usual, when you run into problems, we have an introduction to an opportunity and a solution. That's where those data mesh concept that introduced to at least fix those two problems that we talked about in the data quality and availability side. So it's decentralized, and we're going to talk a little bit more about that. It's using the data product as a concept to drive business value and have more quality with the data that you're using, meaningful data in there. Has the concept of domain ownership, domain-driven design to be able to assign it to a proper group, and also we're going to talk a little bit about this. Embracing self-service and federated governance as a concept. So let's quickly go through those concepts and see that how they are going to help with the problem that we have in here. So I'm going to use a quick example from the banking industry on I would say, the famous or infamous customer model. We have situations that in there that we're on the legacy side that you would think, that we have a canonical customer model. We have only one customer model that's owned by the data team. If we have changes on that customer model, then the data team is responsible really for going and making sure that this canonical customer model that is synchronized across all and applying the changes in the right way to all. And this is not really realistic. That usually not the case anymore. Well, actually, instead, we run with this instead. So we'll find out line of business on their own schema and their own model. And whenever there's a customer change that they need to receive that specific customer change only, and apply to those separate models, where it will be able to enhance and enrich and everything about this business entity within your own domain. So the decentralized model really help us a lot with that versus the centralized. And going through the presentation, you'll learn more and more about this. It actually led to the next concept that we are talking about in here, which is the data product. So data product-driven design is helping us to guide us through improving quality. So whenever we define the business use, we have a better understanding of the data set that we are using it for. And you can see a lot of things that as this example and out there online that show you how to use a template for it in terms of how you'll be able to identify this data set as a business product, right? And drive value from it. Similar to the customer entity that we were just talking about a second ago. The other thing that also that we need to point out, that the ability to use domain-driven design to identify where is this business entity that belongs to, which line of business that will be able to identify the traits that you need to have in this entity, and how you enhance it, how you deal with version control over it, and things like that. That where you would benefit from when you assign it to a party that's really interested in enhancing this business entity and work further with this model. Self-service, it's also very important. So traditionally within the enterprise IT, I guess a long time ago in a different world, before the current business requirement come in and business enhancement that come in, and the new features, or before Agile, governance took a center stage. So you just tell people what they should do and they would do. That's not really 100% the case anymore. Things changed. For a platform to be successful, it must have the incentives. Otherwise people will go and bring in other capabilities that they think that they are more usable and productive. So right now we started to see on the platform self-serve capabilities where people can independently search for the data, metadata, and they would have seamless access to request access to this data, and also easy access to testing and things of that sort. Federated governance is also very important, as you know. So governance in general is important, and it's essential to our data quality. However, when it comes to the distributed and decentralized model that we talked about, it's a lot harder, and we use few techniques in there to enhance on that. Like federated is also the keyword, contract first design, metadata management, early schema validation, and schema versioning strategy. We're going to talk about the early aspect of those and later on within the presentation. So how about the timely aspect? We mentioned that at the beginning, and timely aspect is really very important and essential, but I think it's one of the most overlooked aspects within the whole cycle. And as you can see, it's not specifically part of the data mesh concept that we just went through. And this is why the word why that mentioned at the beginning is very important. As you can see, that if you are late on realizing the business value, then that negatively impacts the business. If we are late on validation, that impacts the data quality. If we don't have timely access to data, that impacts our data availability. So this is really a very important aspect of the whole thing. So how can we fix the timely or untimely aspect? As you expect, we're going to talk a little bit about event stream. So event streaming is really an evolution of the traditional event-driven architecture. it's actually solving many of the legacy EDA, I would say, monolith problems that we used to run into, based EDA or ESPs or things of that sort. So the look appending style that was created in there is really solving a lot of the problems that we ran into that space. We have, for instance, native distributed persistence in there that helps a lot with redundancy and durability of the data. We have reading the message is not a destructive operation. We can go back and replay messages and do time travel. We can do a lot of the things that we couldn't do in terms of the elasticity. We have better performance through parallelism. We have, with the pull-based event streaming through consumer isolation, a lot of great benefits that came really through with event streaming. That actually would be a talk on its own, that when we talk about event streaming platforms. So one of the things that also we see right now, that event streaming is used as an API or internal API, right? So it's used in modern application architecture. It's a core component of reactive architecture and Mac architecture. We use it to build resilient, responsive, and elastic solutions through asynchronous processing and decoupling. And as you can see in there, that it shares a lot of the design pattern also with modern data architecture in terms of domain-driven design or command query responsibility segregation and event sourcing. So this is really very, I would say, successful in the modern application architecture space right now, as and you can see. So how about data, right? So when it comes to data, if you think about it, event streaming can solve the untimely problem for us. So event is not just an API, it's also a data product, actually a timely data product. So if you look into our banking example that we were talking about, if this customer event that coming in as an data product that would have a certain value that where it can enrich those separate customer schemas or data models or entities in a near real-time way. So this is an actual enrichment. Also, using this approach, you can realize the business value early within those lines of businesses. You can validate early, so you can validate the schema on the producer side, also the same as the consumer side, or the line of business or the application. You can transform early, and you can sort of transform in the right way, because now that what you are using, the event or the change on the customer, what you are using it for, and so forth. And if you look at this, you'll find out that really probably that's a term that you would hear in the industry right now, that people are talking about streaming ETL. So aside from the traditional ETL concept and ELT that we talked about at the beginning, we actually have streaming ETL, as you can see in there, that coming in, that we're in this model that you would use the event streaming and the events coming in as both APIs and as a data product, right? So we can support real-time processing. At the same time, you can use it for your analytics. You can support batch processing, and you can improve on the quality of your data upfront and early enough. You can reduce the cost by removing some of the point integration. It helps you with the scalability and agility, and also the timing of the data that we talked about. Now, if you really double click on that, when it comes more to the technology side, you will find out that we are using this in an ecosystem into the world, right? So we are using distributed event streaming with a lot of use cases that were used, as we talked about, as internal APIs and also as data products. And really the line for the technology between the two is blurring right now. So having said that, when you look at this picture, immediately comes to mind when you talk about the how for the data mesh. So you see in here that we have a lot of the traits that we talked about in terms of distributed model, decentralized, having the ability to use a data product driven design, domain driven design, also have federated governance and self-service coming into that space. And we have a lot of vendors thinking about event as data product right now, and actually bringing this to the market. So let me give you a quick demo right now on how someone that actually would bring in capabilities like that within the market space to treat event as data products. So I'm just gonna switch my screen here for a second. So I'm actually gonna borrow from Confluent Cloud. I think it's really a very good example on how they are building story in there around having the ability to present events as data products. And I'm going to here. So this is the Confluent Cloud. So for instance, when it comes to self-service or self-serve portal, it's really good to have everything under a single pane of glass. So if we are talking about the stream catalogs, so you can really, for the customer example that we were talking about in there, so you can find all the things that you need to look for when it comes to the event catalog and the events in one place. This is attached to the schema and schema registry on the governance side. So if I click in here, that will take you to the customer change that we were just talking about in here was the customer activity. If I go back and look at dashboard in terms of having the ability to have observability and being able to view your operational and SLA aspects in here. On the governance side, I'm actually going to show you first the developer ecosystem. So if you go to your clients in here, be able to go to see a library of clients. So for instance, if I want to bring in, for instance, a code that for Spring Boot, I can just go in there and start copying the configuration, create the key for it. So if I go in here for my code, I can easily use that and change my configuration in here and just use a quick startup example to run my code. So it's a very, on the self-serve side, it's a very easy way to start with a project in there. And then you have the ability to work with the connectors for a variety of things that you can do under one ceiling. And it actually, when we run that, we can see in here that see all the activity coming in for that customer example that we were talking about. Also on the governance side, it's very cool that it includes not just the source where the data coming from. On the connector side, it can also show you the topic, can show you the clients that connected to. And I think you can also dive deep from here into all the aspects that are associated with it, the schema associated with it. It has, when you go to the cluster itself, the ability to do backward compatibility. So if we go back in here, on the schema registry setting, right, you'd be able to see, how this is going to work in terms of the compatibility modes and the situation that we are selecting it as backward compatibility. So it's really, one environment that we have everything in one place with the self-service. You think about it, we have the event lifecycle management, event as a product, the event catalog portal, including the search. You have the schema management in terms of the governance, also including the stream lineage tracking on the producer and the consumer side. So it is not just the brokers and what's happening on our topics. It's also including the consumers and the producers on that front. It has a developer ecosystem, connector ecosystem, has the observability and the monitoring. So this is really just an example on event streaming as a platform, event streaming as a data product, and nothing is really stop you also in there from using it as an API. So that brings us back to what we are talking about in here. That really now I think this picture is a lot clearer, right? When we saw the demo, what do we really mean by event streaming platform and event as a data product. So to summarize, we talked about the data mesh and the why and why we have those aspects on improving the quality issues and improving the availability issues for our data. We talked about the how and how we are using event streaming and distributed event streaming as a cornerstone and the foundation for that. We give an example for this on the demo side, and the last word I think wisdom I would say in there that before we switch to the Q&A. Really, I think about data mesh as modern data platform, right? So if we narrow our thinking into it as if it's just a one thing and one thing only, and it's a box, that would limit our imagination of what we can do with the modern data platforms. So I think about it more as, as conceptually as, fixing the previous generation, and this is where we introduce the timely aspects to it, and along with the other aspects that we have within the data mesh space. So I think that would conclude the run. I think we are on time, which is great. And then that will take us to the Q&A. Thank you very much.
Yeah, thank you, Mark, for a very interesting presentation. Yeah, I have a question regarding this event platform, event streaming platform. Could you name maybe some services and popular cloud providers that implement this idea, event platform?
Absolutely. Yeah, so I think you would see it in different variants. So we have cloud native in there. So for instance, on the AWS side, we have a story, with different capabilities on the event streaming and the Glue as a schema management and things like that. On the GCP, we have the equivalent. On Azure, we have the equivalent. But I think that all of them that would have their own. You would have a similar story, but presenting it and using different capabilities also.
Mm-hmm. Yeah, looks like very, very interesting, detailed presentation. Looks like we don't have any questions, but if anybody has questions, you can connect Mark directly. Yeah, thank you very much, Mark, for your presentation. So yeah,
thank you.
Next talk, and the last presentation that we'll have in 15 minutes. So we're going to close our conference to share the results and some interesting information. Please stay tuned. See you soon.
Thank you.
Hello, everyone, and we are going to close our Winter Data Meetup. But before it, the last part where we conclude everything and give you further steps. So, and I want to invite you, I want to introduce you Ihar Kruhlik, data delivery and people and oriented operations, who will help me with it. Igor, please.
Yeah, thanks, Alexander, for having me. Yeah, I'm a data guy, but today, maybe let's finish this marathon on something more philosophical. In the end, this is data Zen. So let's all take a deep breath and maybe appreciate what we are doing here. Of all possible places to be and things to do, you decided to be here and connect. And during these 2 days, you've been listening to smaller stories about the projects, about your personal experience, and bigger ones about like technological trends. And what a journey. 2 days, 20 speakers, 12 different locations, more than 1,300 participants, and eight major themes. How it all became real and why. Next slide, please. So Data Zen is our flagship community, uniting more than 500 different specialists and people passionate about data. We welcome people of all backgrounds, of all levels of seniority. The only prerequisite is interest in data. So we support all the formats and all the major platforms. So you can find us anywhere and consume the information in any convenient format. But still, Data Zen motivates us to invest in our education and career. And in the end, I really believe that it brings possible changes into our life. Next slide, please. So the real call to action here is to participate, not just to consume, but consuming information is also fine. But then if you can be a real part of this big family, please nominate yourself to be speakers. Please be experts and please be fans of that. What you will receive? First, and maybe foremost, you can share your unique experience and knowledge and help your coworkers, help people around who are basically doing the same stuff as you are, but maybe still in the beginning of that journey. As in any community, it's possible to establish meaningful connections with other people who are also passionate about data. And we spend so much time on the work. So it really makes a difference if you really feel that there are people who are also interested and passionate about the same things. Finally, make Data Zen community better, because it's a journey that's been going on for several years already, but definitely we are still progressing and we are still developing and definitely need all the possible contribution that we can have. And finally, it will help to find you solutions and creative approaches to many challenges that you have in your work. And maybe the final one is to have fun. Fun is a great motivator. And this is why we have those thousands of people. And this is why I really think that we will continue doing this in the future.
Yeah, thank you, Igor. Yeah, everything is correct. Absolutely. Yeah, I want to yeah, as you already mentioned, Data Zen Community exists several years, and this time we announce our heroes badges. So we'll give them for moderation, speaking, writing, contribution. So yeah, attend Data Zen Community, participate in it, and be active, and you will get so these nice badges. And yeah, closing Winter Data Meetup, I want to say big thank you for those ones who helped us a lot to make it real, such a big conference. So Anastasia Hulidova, who helped a lot in meetup organization, Volga Bykhovtsova, you could also see her on our talks and chatting with speakers. Андрей Цитrinov, Алексей Малашенко, Максим Скороход, Лизавета Жук, Nikita Zakharenko и Anastasia Tarasevich. They helped a lot with speakers preparation, announcements, creating such a great design of our meetup. So everything, all this helped a lot. Of course, your opinion and feedback is very, very important for us to create such wonderful events and get better and better. Yeah, so you will also receive feedback forms on your emails, but also you can follow these QR codes, scan QR codes, and fill feedback form for us. So it will be very helpful for us. Yeah, please spend some minutes to make us better. And also, I want to ask you that and remind you that you can connect to and subscribe to our accounts in social networks, in Spotify, in YouTube, in Telegram, in LinkedIn, and of course in Wear Community platform. And stay tuned with us. Follow our Data Zen events for get more data knowledge, develop yourself, and be part of this Data Zen community. So yeah, and I want to say goodbye to everybody. See you soon, and yeah, stay Zen. Thank you. Bye.